Hello. Yes. Good afternoon to all respected speakers, dignitaries, and all participants. I am Forum Thakur, on Deputy Engineer JETCO, on behalf of EPD, welcoming you all on the second day of Vibrant Gujarat conference, regional conference at Rajkot. Today, we are here for the seminar and panel discussion of subject name is Cable that enables clean energy, renewable energy interwoven with last mile connection. To move ahead with this seminar, I kindly requested Sri A.B. Rathod sir, CE SLDC, to uh, come here and for his welcome speech.
Good afternoon and warm welcome to all of you. How we can start this session of cable and connectivity? Uh, Close your eyes, take a deep breath. Imagine your position in womb of our mother. As a photos of 5 weeks, our heartbeat just has started, and imagine one connection is already there with your mother and you. That is the connectivity. After our birth, we experience many connectivities: physical, spiritual, or mental. Today, we have 7 mentors and 1 moderator. One by one, I introduce them. Mr. R.D. Bhagia sir, Dr. R.D. Bhagia sir, Associated Professor, Government Engineering College, Rajkot. He is Gujarati and has wide experience of academia. Professor K. Santi Swarupji, he is from IIT Madras and has wide experience of technical and productivity of cable. Actually, as a Gujarat, we have also a wide length of seashore. It is more than 1600 kilometer. And IIT Madras is connected with Gujarat progress with ocean engineering, and that's why we have invited them in that seminar. Third is Mr. Sumit Sanger sir, Director, Bureau of Indian Standard. हम स्वदेशी की बात कर रहे हैं, तो स्टैंडर्ड भी हमें स्वदेशी चाहिए और वो भी बनाने पड़ेंगे, क्योंकि जो भी डाइवर्सिटी इंडिया की है, गुजरात की है, तो वो भी हमारे स्टैंडर्ड से मैच होनी चाहिए. तब जाके हम कुछ अलग कर पाएंगे, जल्द कर पाएंगे और क्वालिटी भी दे पाएंगे. मिस्टर G.H.N. Rao sir, General Manager Project, NTPC Green. He has a wide experience of this terrain. Their projects are generally in implementation stage at Jamnagar and Rajkot. Mr. Adar Singh, Chief Manager, Quality and Control, PGCIL. With him we will learn the quality standard of cables. Mr. Yogendra S. Tiwari ji, Vice President, Universal Cable. Universal Cable supplies cable to all the universe. Mr. Surinder Jain sir, Assistant VP, KEI India Limited. KEI नाम कुछ अलग लगा, नहीं अलग नहीं है. Krishna Electrical Industries is the full name of KEI Industries, and they are also very close to Gujarat. Mr. Jainesh Shah, Proprietor and Founder, KJK Engineering Limited. बात केबल की है तो इंस्टॉलेशन के जो एक्सपीरियंस है वो उनसे मिल पाएंगे. नाउ दिस डिस्कशन इज नॉट लिमिटेड टू इंग्लिश. Bhagia sir is Gujarati. You can spare any type of your question in Gujarati, Hindi, English, whatever is convenient to you. हम आपको ठीक से समझा पाएंगे. अगर गुजराती की ज़रूरत पड़े तो गुजराती में भी हम एक्सप्लेन करेंगे. मैं और मेरी टीम भाग्या सर भी है और आपको पूरी समझन मतलब पूरा अंडरस्टैंडिंग देंगे आप ये पर्टिकुलर चीज़ का. तो विद दिस आई एम ओपन दिस सेशन. Wish you all the best and I wish this session will be productive and very close to our requirement. Thank you.
Thank you very much, Sir A.B. Rathod, sir. To move ahead, as a green sustainable initiative, instead of bouquet, we would like to welcome our speakers, respected speakers, with a book. So I again kindly requested Sri A.B. Rathod, sir, to welcome our moderator of this session, Dr. R.D. Bhagia, sir, Associate Professor, Government Engineering College, Rajkot. And I request Sri Dr. R.D. Bhagia, sir, to take his seat. Now again I kindly requested Sri A.B. Rathod, sir, to welcome our speaker, Professor K.S. Swaroop, sir, from the IIT Madras.
Sir, please enter.
Yeah.
Yes, sir. Sir. Thank you.
Thank you, sir. I kindly request Sri Swaroop, sir, to take his seat. Again, I requested A.B. Patel, sir, to welcome Sri Sumit Senjar, sir, Director of BIS. Thank you very much, sir. Please take your seat. Now I request Sri P.K. Varasra, sir, Additional CE Rajkot Zone JEDCO, to welcome Sri G.H.N. Rao, sir, GM Project, NTPC Green.
Okay, yes, sir. Yes, please. Yes, please, sir. Okay.
Yes. Thank you, sir. Now I again request Sri P.K. Varasra, sir, to welcome Sri Adarsh Singh, sir, Chief Manager, PGCIL.
Yes, sir.
Okay. I request, yes, thank you, sir. I request Sri P.K. Varasra, sir, to welcome Sri Yogendra S. Tiwari, VP Universal Cables.
Yes, please. Sir.
Sit, sir. Thank you, sir. Now I request Sri N.M. Seth, sir, in charge Additional CE Engineering JEDCO, to welcome Sri Surendra Jain, sir, Assistant VP KEI India Limited.
Yes, sir.
Thank you, sir. I again request Sri N.M. Seth, sir, to welcome Sri Jinesh Shah, sir, founder of KGK Engineering Limited. Thank you very, thank you very much, all speakers and dignitaries. Now, to move ahead with electrifying panel discussion, I would like to hand over the session to moderator Dr. R.D. Bhagia, sir.
Hello, hello. Good afternoon to all. As my introduction has been given, and today we are meet here to make discussion on cables enable clean energy, right? So we know we know that. Hello, hello. Cable that enables clean energy. As we know that the power sector of India is moving at a very fast rate from conventional sources to our renewable sources. And Gujarat is a state which is taking right now leadership in India. So in India, we know that the power sector is changing and more renewable sources are integrated and we are becoming free from some conventional sources and we can contribute zero emission. Now we know that our Honorable Prime Minister has set a goal of 500 gigawatt by 2030. And up to now, we reached at 205 gigawatt from different renewable sources. And it is at the end of December 2025. Now we have a 4 years, and within these 4 years, we have to move with a very fast speed. Then and then, 500 gigawatt can be achieved. So for that, what we have to do? So the question is, what we have to do? We have to move towards the potential of renewable energy where we can harvest it and we can utilize for the, our country. So for that, we know that two states of India having a enough wind speed and also steady wind, especially Tamil Nadu and Gujarat. Approximately 80 gigawatt capacity we have. And if we can harvest this wind energy, then it is very good contribution to achieve 500 gigawatt by 2030. With this vision, we are here under the umbrella of Vibrant Gujarat Regional Conference 2026. So here we have a very eminent speaker. They are from industry, they are from manufacturing sectors, they are from academic, from research, from some consulting firms, from Bureau of Indian Standard and so on. So if we can say that if the knowledge required, how can we capture the energy from ocean sources and we can utilize it? For that, loads of challenges are there. So whenever we are seeing onshore, if we are installing wind farm, then we are also facing many problems. But we are thinking here to install in offshore. Actually, this is a very mature technology as far as developed country are concerned. Even worldwide, if we see the scenario, 80 gigawatt already has been installed and working very well, especially in European countries and China. China is half of the total global installed offshore power capacity. So what we have to do? So as we know that here we have experts and we today try to understand what is the vision of our Prime Minister and how can we achieve it. For that, we have to work as a chain. One output give another for the input and second output will be the input for third one and so on. So combinedly, we can do something in this matter. So here, if we think only cable infrastructure, sir has said that the connectivity is very important because we have to install a cable on seabed and there are lots of issues over there because if we think simply when fault occur then what will be happen, wind turbine in offshore condition are range from 8 megawatt to 25 megawatt. And if we think 30 gigawatt capacity as far as Gujarat is concerned, then if for a 2 days this pooling station will be remain closed, then what will be happen to the grid? So we have to think the security, reliability, and stability of the grid also. Whenever some cable network will comes, marine cable network will comes and effect definitely on the grid which is installed on shore also. So in next couple of half an hours, we will discuss on it, and step by step we will do it. So every speaker may get 7 to 8 minutes, and after discussion of 8 minutes, some question will be taken from audience. Quick question it should be during the session completion of each speaker, so we can save our time. And at the end of discussion of all the speakers, what will be happen? We will make in-depth discussion and question answer also. So whenever some question arise from audience, please ask the question to the speaker, so they will share their expertise in his domain, and we can understand that yes, what is the objective of this one and what's the outcome at the end. Now, I request all the speakers come over there, and one by one we will start our presentation so everyone can easily enjoy it. Okay? So meanwhile, if you have any question, please note it down and ask the question. So it will be bilateral. It will not be a unidirectional. Thank you. Now I request Rao sir from NTPC present his experience in the installation of wind farm, what are the different challenges and what are the possible other challenges in offshore wind turbine. Over to Rao sir.
क्या हो तुम यहाँ था ना तो क्या हो अभी तो आया और कोई नहीं है अब 10 मिनट हो गए अभी तो बात कर रहा हूँ ना
Hello. One more thing here. At the end of 7 minutes, some clock will be run here, and it is then after within a minute we have to complete our presentation.
Good afternoon, everyone. Most respected dignitaries, speakers invited for this session, and participants, and our industry co-partners. Greetings of the day from NTPC Limited. I am G. Harnaran Rao, accompanied by my colleague Mr. Binay Gurdev. Thank you, Gujarat, and thank you, EPD department, for inviting us for this session, sir. Sir, as you all know, NTPC is leading India's power sector and driving sustainable growth and spearheading the energy transition of India. We have around now 85 plus gigawatt installed capacity, and 13 plus gigawatt is under commissioning. It is under implementation. And we have a share of 24% in all India generation. And the company's aim is to become 60 gigawatt renewable energy company by 2032. As we all know, sir, as India is scaling renewables rapidly, and NTPC is also spearheading this energy transition. So in this interaction session, I will briefly touch upon my experience with the onshore wind energy projects execution, what are the challenges we have faced, and I will touch upon offshore also, what are the challenges and where India stands right now at this moment. And finally, last but not the least, the what is the challenge and the present challenge and the theme of this today's session, that is the last mile connectivity, how we will integrate with the grid, the power. So now coming to the onshore wind energy project, our Indian industry has matured enough that they have mastered all the steps of project execution in wind energy project of onshore. From starting from civil activities to mechanical erection activities, and coming to our SCADA also, all these things have been step by step they have mastered, and there is no doubt that we are not able to execute on this spot. And there are some issues with the execution of wind energy projects, like material transportation of this heavy equipments and this oversized cargo. But these are, and there are some issues also due to that government of Gujarat bridge closure. In government, we have faced issues during logistics, sir. And there are some issues with the village access roads also. And especially in this RE domain, trained manpower is not available in Gujarat, sir. And that is also we are working with the MNRE to see how to partnership with the ITIs and polytechnics and local national skill development centers. That is also. So what I can say is all these mentioned in this slide, they are mitigated somehow, are being mitigated with the support of government, with the support of local community, with the support of the district administration. And going through all these steps, the WTG erection, now I have erected, we have erected a wind turbine generator. So next what to do? That is what is the theme of the session, that cables that ensure connectivity. Now, sir, resolving all these issues, now we have to bring this 33 kV network. We have to build a 33 kV network, starting from the wind farm to a pooling substation. From there, we have to take this power to the evacuation station at 220 kV level, or sometimes if it is with connection with the GETCO, 66 kV level. But here comes the question, sir, how to build this connection. This grid connectivity is a very big challenge. I think there are, we all know, but I have compared some future strategies which can be taken forward, which has to be taken forward by NTPC along with the academia and industry and our industry partners and our EPC contractors also. So right now this overhead transmission line, which is easy, not very easy, but it is a mature technology, and we have got plenty of manpower to build that, and the fault detection and everything is visible and it can be detected at any time. So what we have to go, sir, instead of building different transmission corridors, we have to build a dedicated transmission corridor. So where the ROW issues are already resolved or are in the process of resolving. So this will at least reduce that this corridor is a special corridor which is meant for only transmission line construction, building of transmission line infrastructure. Otherwise, if every RE developer starts building his own network, so it takes a longer time, sir. And there is a lot of uncertainty in completing the project. So this is one thing. But however, even building a dedicated transmission corridor also not an easy thing. You have to require consent of the local community, consent of the local administration, and so much support is required from the public. And it's also not easy. But however, this dedicated transmission corridors are to be envisaged or to be built wherever some GIB zones are there, sir, in Kutch area. So that is compulsorily we are building. So there is no other chance that there is no other option also there. And there is the next technology that we have to move forward gradually, but not now, but it may become a choice now, but it will become compulsory in future. And because of the larger footprint required for overhead transmission line. Overhead transmission lines requires a lot of land. So whereas this underground cabling, it requires a lesser land compared to this overhead transmission line. And they are much more fault tolerant and they are not susceptible to weather, sir. any weather, bad weather is there, anything is there, any storm or cyclone is there, they are not susceptible to such kind of disturbances. However, the cost is high, but as I told earlier, this is compulsorily required as per government norms. Wherever wildlife zone is there, wherever GAB zone is there, or congested corridors is there, already we are building. But in future, sir, now we are discussing today, down the lane after 5 years, we may go for this technology, sir. And sir, the next thing that Bhagya sir is telling, that this about this ocean, that is subsea cables, this will completely avoid these ROW issues, at least which if anybody executed a project, they will be knowing what is the toughness into required, and what are the kind of support, what are the kind of departments who have to take support, public also. So this will completely bypass the requirement of any land, sir. So this is very good. However, this for short distances it is not viable, sir. For for 15 kilometers, 16 kilometers, even for 50 kilometers also, if you want to go undersea and you want to build, that itself is a huge cost, and that capital cost is very high, and we don't have enough matured industry right now in India. However, through this seminar, we are laying some kind of provocative thoughts in the industry as well as our EPC contractors, that down the lane, maybe in future, wherever the projects, that RE projects are nearer to ocean, we may go for this kind of technology, sir. So this is all about onshore projects and how we are trying to get it connected, and how we are trying to migrate towards a future more resilient technologies. Now coming to this offshore technology, so Government of India is trying since October 2016, the MNRE has notified a policy, and it was told that National Institute of Wind Energy, Chennai is the nodal agency. But this anything you want to build in the ocean, it requires around 7 ministries in stage 2, stage 1 5 ministries. That approval is required. That was a tougher task. And later in August 2023, this MNRE has again come with a new policy that they have identified more clusters. In Tamil Nadu, 1 cluster, and Gujarat, 1 cluster. And power allocation and ISTS waiver was also given. And they have introduced different kinds of viability gap funding models, and a lot of incentives also they have provided. And that auction trajectory was from 26 February, this financial year 26 to financial year 30. Gradually we will auction up to 37 gigawatt. However, there are a lot of tenders that have come through SECI, that have come through MNRE, and there were a 0.5 gigawatt blocks that are to be executed in Tamil Nadu coast and along with Gujarat coast. But these tenders could not be taken forward, sir, because no technology provider has come forward. This is due to the immature ecosystem, that we don't have sufficient skilled manpower and as well as vessels, and that kind of technology is also not there. So right now, at this point, we can say that instead of going for that 0.5 gigawatt projects, if any investor wants to put money, he will think of the cost economics. So that block should be 1 gigawatt, sir. And if it is built on the offshore, if it is an offshore plant, it should have a storage kind of facility, so that it can be given to that next evacuation point. And this taking approvals from 7 ministries is not possible for any developer, sir. That there should be only one single window authority who can give an approval for this. And this timeline, being a new projects, you cannot execute within a short period, sir. Minimum 8 years timeline is required for this kind of projects. And sir, to conclude, actually right now and at this moment, we can say this underwater technologies, undersea technologies, undersea cabling, the submarine cabling, it may be a luxury, it may be a choice, but if you see, sir, the technology, it will not leave you. You have to drive, otherwise it will drive you. So over a period of maybe within 10 years, we have to go for this marine kind of cables. So for this, we need support from the industry, from the government in formulating policies, and as well as the EPC contractors. And NTPC always tries to help or handhold or mentor any kind of company they want to do any kind of experiment. So this is all from NTPC side, sir. Thank you, one and all. So thank you for inviting us. Thank you for inviting NTPC for this seminar, sir. Thank you, sir.
Thank you, Rao sir. He has given us lots of information regarding what are the challenges and so on. Definitely, underground cable may be cheap because day by day cost of land is going to be increased. If you think the cost of land before 20 years and right now the cost is different, it may be happen after 20 years, cost of land is so high and the cost of the cable will be very less. So it may be happen in future. So any question from audience, you may ask please. You may ask in Gujarati, you may ask in Hindi, no problem. But if you ask the question, we can understand that you know something from us. Okay, sir. Thank you. Now,
No questions? Thank you, sir.
Since nobody is asking,
Sir.
if I can. Sir, you talked about the challenges of submarine cable installation, in particular technology part. You have touched based upon the approval part, number of ministries, so that is a bureaucracy problem. But what technological challenges you are talking? I mean, can you go in detail about technological challenges? Because I don't understand.
No, sir. Actually, what I mean to say the technological challenge. Suppose if I am going to install a renewable energy project, which is nearer to sea, even though if it is onshore, but it is nearer to sea, their laying of transmission lines. So these towers over a period of time they catch corrosion, sir. So maintaining these cables, maintaining these towers, they will be very difficult. So if there is a project, if in future it is coming nearer to the coast, but it is on onshore, then there is always possibility that I will take that cable to the undersea, and again I will bring after some maybe 60, 70 kilometer, 80 kilometer or 100 kilometers, or maybe longer distance also. I will again bring it onto the best system or like that. So that is what I want to mean.
So
Yes, sir.
corrosion is an issue. That's
Yeah,
what you
corrosion
meant.
is an issue, sir. That
Okay.
cables
So
right now.
so selecting cable for the last mile connectivity.
Yes, yes.
There is no technological changes, correct?
Yeah, there is no technical change. India, we can easily adopt, sir, but that industry has to help in identifying the right cable for the right project. Suppose if I am installing a project which is very far away from sea coast, then there is no need of thinking about this corrosion, like the towers catching corrosion, or these cables. Even that insulation also gets damaged even in this saline weather, sir.
Yeah.
That we have seen. So even it is sweet water. We have projects across India, sir. Those are floating solar projects. And these floating solar projects, they are built on sweet water, and nothing should happen. But a particular floating solar project is nearer to coast. Even the cable selection was good for that sweet water, but they have not taken consideration of the yeah. So that local weather conditions were not taken care.
So that
So
was
again,
a
we have to rework, sir. So this
that
is
was
where
a
the
design
industry
fault.
comes up. Sir.
That was design fault.
Yes, sir.
the
Design
time
fault,
of- yeah.
right, sir. At least that is what I mean to say. Ki the industry has to come to the developer at the right point, right moment. So after that, they come and they give solution, and at that time, say already the project is already built. Thank you, sir.
Thank you, sir.
All manufacturers have a capability of manufacturing the land cables, and they have a sufficient experience how to lay the land cables under the different conditions. In India right now, as you said, there I no manufacturer who can manufacture the cables of cables, especially, and second one, especially who can lay the cables. It is the biggest technological issue.
I beg your pardon, sir. That is not right.
Okay.
Yeah, in India there are a lot of companies available. Right now I am from KJK Consulting Engineers, but I have worked abroad for 30 years, and I have worked with several companies who are having branches and they are operating in India and laying submarine cables.
But are they having
Absolutely.
sufficient vessels who
They-
can take the cables
You
and
see-
lay the cables?
You see, in the international market, there are hundreds of submarine cable being executed right now as we speak. Available, everything is available. It's a question of only tapping. You need to ask right questions to the right people. All vessels are available.
Okay.
South Korea, China, plenty of vessels are available.
No,
And there
just
is
we are talking about the India, no.
no.
Yes.
Not necessary, no. For example, you will procure cable from abroad. You will take vessels also from abroad for transportation, for laying.
Okay, all such kind of conversation we will make during panel discussion. Okay, so
Thank you.
right now we will go one by one presentation. Okay. Now I request Sri Singh sir to give his presentation.
Good afternoon, everyone. I'm Adarsh Singh, working in Power Grid Corporation of India Limited. Mainly, I'm having experience in design of substations. So that's why we have done some projects of underground cables up to 400 kV in India. So I was just listening the discussion just going on before that. So in the EHV cable, if we talk about the AC cables, we are having a really good experience in India, and we are also having the laying experience. All the manufacturers are sitting here who are already doing it. But if we talk about this submarine, undersea cables, and offshore cables, so for that, as sir is saying, the equipments and machineries are available, but they are already overbooked for next 8 to 10 years. So if we are talking about we need the project 10 years, after 10 years, then we can think about today. So this is the main concern. And in the India, we don't have industry who is manufacturing the cables because it is a huge quantity. Like if we are thinking about different countries interconnection like India to Singapore, India to UAE, then we require minimum route length of 1000 kilometers. So it's a huge quantity. So there are some technological gap right now. We have to think how we can fill it. Okay. So sir, already Rao sir has given some differences between overhead, underground and the subsea cables. So I will mainly discuss about the offshore projects and the HVDC cables, which are currently not available in Indian land, but we have to do in the future because this is the future only. Because in the AIS cables, like EHV AC cables, we have some limitations. Like we cannot run those cables for more than 10 kilometers for 400 kV, and we are having the biggest size available in India is 400 kV for. So that is the main challenge. So in the DC, we don't have this limitation of laying for a longer lengths. So in the future, we have to go with the HVDC cables only. So we can discuss about that. We have some photos also, so everyone can see and relate it, how it's working. So if we talk about this offshore, so right now in Government of India has already sir told until 2030 we have to install 500 gigawatt of renewable energy. So already wind energy is of 118 gigawatt. And in Gujarat, from the offshore, we have to take 36 gigawatt. We have the capacity. In Tamil Nadu, we are having near about 35 gigawatts. And as the power grid, we are currently in a process of doing the 500 megawatt project of offshore in Gujarat as well as Tamil Nadu. There are some delay from the ministry end. There are some changing in the scope of work. Otherwise, we have already floated the tenders for the Gujarat, and we are having some parties who are doing it, and we are having their consent on that. So by 2030, we are having identified 10 gigawatt, 5 gigawatt from the Gujarat, 5 gigawatt from the Tamil Nadu, and the distance from the shore will be nearly 40 to 50 kilometers. And the depth of water we have seen in Tamil Nadu and this Gujarat region is 10 to 20 meters. So total requirement will be nearly 1,000 kilometers, and there is some figure of estimated cost of nearly 28,000 crores investment in this. So this is some representation. This is first one from the Gujarat area. How we are going to take it to the from the offshore to the land onshore, and then connect to the main grid. Same for the this Tamil Nadu area. We are going to install in these areas the offshore wind turbines. So this is the total scope. First of all, these wind turbines, which will be developed by the RE generators. Then from the offshore substations, the TSP scope will come. We will give the transmission network. So this offshore substation will be built in the undersea, and then from there we will connect to the main onshore substation by the underground cable, and then we will go connect with the main grid from the overhead lines. So from this undersea cable to the onshore, we have to connect undersea cables as well as the underground cables both, as per the requirement. So mainly this is the offshore substation. You can see in this one is top side where substation is there. Then the jacket and pile foundation we can see in this yellow color. Then electrical equipments will be there in the mid of there. There will be a substation of nearly 25 kV, and it will convert 25 kV to nearly 220 kV, in which we will going to transmit the power. And further, I will discuss about the HVDC projects which are going to come in the future. The ministry is already doing some work on that. We are already doing some consultancy work for the this Andaman projects, in which we are going to connect the Andaman with nearly 500 megawatt with undersea HVDC cables of plus minus 320 kV. And from Andaman to Nicobar, it will be 250 megawatt. So we are going to connect this Andaman Nicobar with the HVDC cables, undersea cables, in the future. And this implementation schedule is nearly 5 years for this. So like this from Odisha, we are going to connect the Andamans. So we have already done the preliminary survey of the undersea. So the maximum depth is coming near about 2,737 meters. So this will be the technical requirement, because in the world we have not done this depth of work till now. So we are working with the manufacturers and the executing companies. Then we are also going to connect India with Sri Lanka with VSC HVDC of 1,000 megawatt, in which the depth of the sea will be not much. It will be, I think, nearly 10 to 12 meters. So it's less depth project, and we are going to connect from this Rameswaram area to the Sri Lanka. And another project we are going to discuss will be from India to Singapore. We are going to connect via undersea cables or via land or via the overhead transmission lines. This is also a future projects we are going to do in future. But currently, these all projects are under pipeline. Nothing is under execution. But because for this, if we are planning, I just told you, we have to plan today for the next 10 years. So there are three options: via sea, via land, and via overhead lines. And the next one is the Middle East. We are connecting the South Asia country also with the Middle East, and for this already we are under process, and we have had a consultation with the help of CA, who is doing this survey of all the undersea uh, survey, and also giving some important recommendations that how we can establish the industries of this HVDC cables in India. What will be the requirement of manpower? What is the cost requirement? And this is already undergoing. We already have had for this, and CTO has also had one consultant for this. So both the agencies are doing parallel. One has had the fish. This I just forget the name of the agency. It's Fishner. Fishner they have hired from the CA. So it will be nearly 1450 kilometer route length under bed sea cable of nearly the highest depth here. It is 3480 meters depth under undersea. So from India, this is the future interconnection with different countries in the next 10 years in the Southern Asia as well as the Middle East. So this is the complete HVDC links which already available all across the world, as well as which is proposed. The operational one is red, highlight with the red. This yellow is dotted one with under construction link, and the yellow one is the proposed links which we have discussed from the India. So this is the complete network of undersea cables which is already available or to be proposed in the future. So as per the experience, the deepest link in operation is of 1600 meters, and it is of plus minus 500 kV. It is between the Italy, and it's 420 kilometers. So this was done by Hitachi, cables by Pressman, supplied by them. And the longest link we are having till now is 730 kilometers with the depth of 700 meters. So till now we are having only this much of experience available across the market, and our requirement is much higher than the available in the market. Like we are searching for 3700 meter depth requirement, and here we have done till 1600 meter till now in all across the world. These are some under construction networks in Italy and the Greece. So these are some photos of some cables like array cables, then HVDC export cable, AC cable, then EPR, then 3-core AC cable, then MI insulation cables. So mainly this is the photo of the cable storage for the undersea cables. So we have to establish an industry which is near to the shore, which in the sea, so that we can just manufacture the cable of long length and just transport in the vessel, and we can do this laying as well as the trenching of the cable. So this is the cable installation, how they do. There are two vessels parallel working. One is laying the cable in the sea, and other one in the yellow color, they are just trenching it, post laying. So the main concern, these vessels are already booked for so many long durations, like for next 5 to 6 years. So if we are trying to go for a project for in the next future 10 years, then we have to book them right now. So that is the main concern. So there are some coiling of cable, then payout, then unducting, then installation, then shore landing near to the onshore, then some testing photos. They are from all across the manufacturers available. So main causes of cable failures are mostly 46% are due to installation, then nearly 15% due to wrong cable design, some 8% are due to external damage, and 31% due to manufacturing. So this is the main causes. Like many industries ask what are the causes of the cable failures. So this is the bifurcation of that. So everyone is part of this. all the manufacturers as well the EPC. So challenges, Rao sir has already told us, the clearances and approvals from different ministries, this is a long-term process, it takes time. So this is, we cannot do in that anything, this is a bureau. Then hostile marine environment, like we discussed about salty, corrosive, windy environment, the hurricanes sir told ki this is the technical reasons. Then supply chain gap, limited number of vendors we are having. Then non-availability of domestic suppliers, and what I told, all the vendors who are available globally are already booked for the next 4 or 5 years. The logistics challenges, the limited vessels for installation and transportation. These are the major challenges, and the main one is the skilled manpower. So cause this is the biggest challenge in India, ministry is doing on it, they are doing some workshops on this challenge, but still we are facing this challenge on the cable industry. So main manufacturers as of now we are having all across the world are Prysmian, Nexon, NKT, Sumitomo, LS Cables. So these 4 or 5 only all over the cross globe, the available manufacturers are there. So we are going with them, but I urge to, from this forum, to all the Indian manufacturers, you can do the joint venture technology transfer with them and just establish factories in India. It will enhance all the things, like it will be Indian indigenous product, then the jobs will create in India. We are already doing the best technology in India, like STATCOMs, synchronous condenser, SVCs. We are having 1200 kV AC system in power grid. So if we are going upscales in all the platforms, then why we can't go in this? We have the capability, but we have to explore it. Thank you so much.
Thank you, Singh sir. Really very interesting presentation and very, very informative what is going on and so on. So we can see the future also, what will be happening in India after 10 years, right? So request from audience, please question.
Cable is continuous cable or cable joints provided between?
In the land cable, as per the transportation limitation, as on date, we are having maximum length of 500 or 600 meters. So after 500 meters, we have to provide the joints.
So who are the cable joint manufacturer?
The same cable manufacturers, like in India for 400 kV, there are 4 or 5 manufacturers who are available. Like this KEI is manufacturing, then Universal is manufacturing, LS Korea is manufacturing.
They are
Yeah.
manufacturing only cables, not
Yes.
cable kits.
The cable kits they are
Joint kits.
procuring from other manufacturers.
But India is not available any EHV cable joint kits.
I think the cable manufacturers can answer your question better, because they are directly connected with them, because we give the EPC contract to them, but they execute it with their cable termination vendor as well as the cable jointers.
So can anybody see?
Yes, Mr. Tiwari is here.
What was the question?
Which are the cable manufacturers in India and kits and joint?
See, none of the cable manufacturer is making accessories. So one should be clear. As far as accessory manufacturers are concerned, there is Rekem, there is 3M. So Rekem, as per our understanding, they are making up to 2 in India.
Not for only for 132 kV, 220 kV they are still performing not well, and no performance for 220 kV.
They are manufacturing. I mean, performance. If you are the user, you can tell me better. But they have manufactured. Yeah. So they have manufactured. They have tested it. Type tested
And
it.
for
speaker-
500 kV and above,
No, actually about 220 kV, no who is manufacturing accessories. Cable we are manufacturing. We are manufacturing. As transmission is concerned up to 400 kV voltage. So we are making cable up to 400 kV, and we can provide accessories from our partners who we have association. As sir was saying, these are normally turnkey contracts. So we provide complete solution, cable, accessories, installation, testing, everything.
but other than Rechem, another manufacturer, is there another manufacturer in India for cable kits?
Cable kit, I mean,
Cable terminations.
cable
Cable
termination,
termination kit?
cable termination mainly who are in bigger range, they are Rechem and 3M.
So in India, only two parties are available, Rechem and 3M.
But
They
3M
are not. They are
only
not
for
for the higher
66
voltage
kV.
level. Yes, they are up to
66
132 kV. You are saying right? Because
Yeah.
I have also visited the Rechem, the manufacturing unit. So they are manufacturing the 145 kV joints and the
220
cable
kV,
termination only.
220
Yes. Okay. No, 33 kV, there are so many manufacturers. We see is talking about the EHV, like 220 kV, 400 kV.
and 400 kV
Or the
cable
HVDC
and
cable
termination
joints.
kit and joining kits.
Normally, I mean, Frontech is making up to 33 kV, and otherwise, for all these submarine specialized cable, you have to talk to the OEM only. For example, in your list, no,
Yes. So
Precision.
NKT, Sumitomo, they are manufacturing their own joints. Yeah.
But NKT not offering inspection of their products. They are only supply the cable kits, not offering any inspection at that
They are
works.
only manufacturing plant.
Yeah.
No. For example, Prysmian, I have executed 2 projects with them, and actually, it's bit early now. I wanted to show you, this is the slice
Yeah.
which we have installed in Saudi Arabia, okay? And it was through Prysmian. So all these slides, what you have shown, no? Exactly same thing.
Yes, yes. The
So-
product, the specification cable type will be the same of all the manufacturers. And
Yeah.
about some design changes will be there.
And I myself went to UK and we procured as a precaution 3 numbers, these cable termination kits. And those termination kits are normally 7 meter long.
Yeah.
So it's a very big one. And the Prysmian themselves supplied. And our contract, because we purchased 90 kilometer cable, and the cable length, single cable length was 36 kilometer. What you were saying here, 400, 500 meter maximum. This cable, the single cable length was 36 kilometer without any joint.
For which
From
voltage
factory.
level? For which voltage level?
36 kV.
36 kV there is
I'm
a
li-
length.
no.
Yeah, I am talking about 400 kV.
No.
Yeah.
Whether it's a 400 kV or 800 kV, the limitation is mainly on the factory, etc.
The transportation limitation are
Transportation
there.
limitation.
Yes, yes.
So if it is a 400 kV cable, but you can go for smaller. The bottleneck is vessels storage capacity. If you have bigger vessel, you can't. So that is the case. So, and all these big manufacturers, Nexan, Prysmian, J-Power, ZTT, they provide also the jointers. So you have to purchase cable termination kits from them, and in case your cable is broken, you have to call them. They will come and make the termination.
No, but madam's question is they don't conduct the inspection at their own premises.
You see, it depends on your contract. At the time of placing purchase order, for example, I myself have gone to Prysmian facilities 3 times. We tested the cable there. It is called factory acceptance test. Once factory acceptance test is over, you take the delivery of the cable through a jetty, what you have shown. You take the delivery in your own vessel. Then you go and you lay. After you lay the cable, first is mechanical completion, then installation checks, then you start the commissioning. So commissioning typically includes first the continuity, partial discharge, HV. Now at this time, if you need them, in your purchase order you have to specify. Then they will send. They will send along with the equipment also. And if you say, no, we have the equipment, test equipments, you just send your technicians to supervise or guide or witness. And in fact, it is a very good practice to compare the test results done in factory and test results done on the site. Because that's how you develop the confidence that cable is intact. Because what happens in submarine cables, during laying, there are lots of forces and kinks are being introduced. So when you see that partial discharge test done in factory and the result on offshore is more or less same, then you are sure that cable has not developed any micro cracks. So everything is possible, madam.
But now NKT not agree for inspection and also offering long duration for supply. They are not supply within 1 year because
Yeah, but
our line is requirement
if their
commission.
factory is full, how can we say?
So other
These are different.
We will discuss at the.
There are different things.
We will discuss in detail in panel discussion, please. Otherwise, it's okay, all participation, but other experts, right, the very prominent expert we have, and we want to take its benefits also. So whenever some question you may write, no problem at all. We will discuss at the end of this session. So now, thank you, sir.
Thank you so much. Thank you, everyone.
Now I request Sumit sir to give his presentation.
नमस्कार, मैं सुमित सेंगर, मैं निदेशक और प्रमुख हूँ भारतीय मानक ब्यूरो अहमदाबाद का। भारतीय मानक ब्यूरो, आप में से ज़्यादातर लोग वाकिफ़ होंगे उससे, जो नहीं जानते तो उनको बताऊं कि वी आर द नेशनल स्टैंडर्ड्स बॉडी ऑफ इंडिया। वी सेट स्टैंडर्ड्स, हम भारतीय मानकों की संरचना करते हैं। तो अभी शुरू में राठौर साहब ने बहुत अच्छी बात बोली थी कि जब यहाँ बात हो रही है हर घर स्वदेशी, घर घर स्वदेशी, तो हमारे मानक भी स्वदेशी होने चाहिए। तो यकीन मानिए इसी उद्देश्य के साथ स्वतंत्रता से पहले 6 जनवरी 1947 को भारतीय मानक ब्यूरो की स्थापना की गई थी। उद्देश्य यही था कि जब देश स्वतंत्र हो तो उस समय हमारे अपने मानक होने चाहिए। तो उस समय इंडियन स्टैंडर्ड्स इंस्टीट्यूशन के नाम से हमारी संस्था की स्थापना, जो ISI मार्क आज घर घर में गुणवत्ता का परिचायक है, तो वो उस नाम से हमारी संस्था की स्थापना हुई। और जो हमने पहला मानक बनाया वो था भारत के तिरंगे का मानक, जो इंडियन नेशनल फ्लैग IS-1 इज़ इंडियन नेशनल फ्लैग स्टैंडर्ड। और तब से लेके अब तक अत्यंत गर्व का विषय है कि हम 23,500 से अधिक मानकों की संरचना कर चुके हैं, जो हमारे और आपके जीवन के हर आयाम के मानकीकरण आवश्यकताओं और अपेक्षाओं, आपकी स्टैंडर्डाइजेशन की जो नीड्स हैं और जो एक्सपेक्टेशंस हैं, दोनों को भली भांति एड्रेस करने के लिए समर्पित है। तो जहाँ तक भारतीय मानक ब्यूरो की गुजरात में बात करें तो बड़े गर्व का विषय है कि यहाँ गुजरात शायद चुनिंदा ऐसे राज्यों में से होगा जहाँ गुजरात सरकार यह सुनिश्चित करती है कि वो BIS के साथ कदम से कदम मिला के हर प्लेटफॉर्म पे क्वालिटी और स्टैंडर्डाइजेशन के प्रति वो अपना कमिटमेंट ना सिर्फ रखे बल्कि उसे समय समय पे वो प्रदर्शित भी करती है। और जिसके चलते जो गुजरात प्रोक्योरमेंट पॉलिसी है जो 2024 में आई, तो उसमें उन्होंने सुनिश्चित किया है कि कोई भी सरकारी खरीद अगर होगी तो उसमें मानकों, भारतीय मानकों का रेफरेंस अवश्य होगा। तो उन्होंने अनिवार्यता को, इंडियन स्टैंडर्ड्स की अनिवार्यता को सुनिश्चित किया। जहाँ तक केबल के स्टैंडर्ड्स की बात है तो ऑलमोस्ट ज़्यादातर स्टैंडर्ड्स ये क्वालिटी कंट्रोल ऑर्डर के तहत ऑलरेडी भारत सरकार द्वारा मैंडेटरी रिजीम में ले आए जा चुके हैं। तो उसके बारे में अभी हम थोड़ी चर्चा करेंगे। और शुरू करने के लिए जैसा मैंने बताया कि देखिए ये हर मौके पर, चाहे वो कंज्यूमर्स डे हो, चाहे हमारा फाउंडेशन डे हो, चीफ मिनिस्टर साहब ये सुनिश्चित करते हैं कि एक ऐसा मैसेज आम जनमानस को जरूर चाहे जो ये दिखाए कि गुजरात सरकार कितनी कमिटेड है स्टैंडर्डाइजेशन और क्वालिटी के प्रति। सो दिस इज़ अ मैसेज वी जस्ट रिसीव्ड। हमारे 6 को हमारा फाउंडेशन डे था, उसमें उन्होंने बताया कि कितना ज़रूरी है। और आदरणीय प्रधानमंत्री जी का भी जो मंतव्य है कि विकसित भारत 2047 तक बनाना, उसे सुनिश्चित करने में भी मानकों का कितना महत्व होगा। कारण कि आप सभी अलग अलग स्टेक होल्डर्स हैं, विभिन्न हितधारक हैं जो अलग अलग सरकारी योजनाओं को संचालित करते हैं। और किसी भी सरकारी योजना की सफलता का परिमाप यही है कि उसमें जो आप उत्पाद प्रदत्त कर रहे हैं या जो सेवाएं आप प्रोवाइड कर रहे हैं वो किसी ना किसी मानक के अनुरूप कसौटी पे खरी उतरे। तो आप लोग जो सामान्य भाषा में जो टेस्टिंग कहते हैं, मैडम अभी कह रहे थे कि फैक्ट्री में टेस्टिंग नहीं होती, ऑन साइट टेस्टिंग नहीं होती, बेसिकली टेस्टिंग, ये सब मानक यही सुनिश्चित करते हैं कि आपके पास एक कसौटी हो जिसके अगेंस्ट आप टेस्टिंग करें। और सबसे इंटरेस्टिंग बात यह है कि इनफैक्ट हमारे गुजरात सरकार के साथ एक स्टेट लेवल कमेटी है जो विच इज हेडेड बाय नन अदर देन द चीफ सेक्रेटरी, जो ये सुनिश्चित करते हैं कि सारी स्कीमों में, सारी योजनाओं में भारतीय मानकों के महत्व को सुनिश्चित किया जा सके। और जो मैंने मानक बताए 23,500, उसके अगेंस्ट आज की तारीख में राष्ट्र में 51,000 से अधिक ISI मार्क के लाइसेंस हम लोग ऑलरेडी प्रदान कर चुके हैं। और अत्यंत गर्व का विषय, उसमें से 12% से अधिक अकेले गुजरात में लाइसेंस संचालित हैं। और इनफैक्ट उनमें सबसे नए इंट्रेंट के रूप में तो शायद KEI से कोई, हाँ इनकी भी एप्लीकेशन आ गई। इनका दे हैव सेट अप अ वेरी ब्यूटीफुल प्लांट एट सानंद। और अब ये गुजरात के होने वाले हैं, हमारे एक नए लाइसेंसी के रूप में हमें ज्वाइन करेंगे। तो बहुत बहुत स्वागत आपका भी। तो ये इन सारे, अब जैसे अभी हमें फाउंडेशन डे मनाया, फाउंडेशन डे में भी हमने सुनिश्चित किया कि फाउंडेशन डे के उपलक्ष्य में लोग तरह तरह के इवेंट करते हैं। हमने क्या किया, UGVCL ने हमसे रिक्वेस्ट की थी कि उनके इंजीनियर्स को स्टैंडर्डाइजेशन के ऊपर ट्रेनिंग देनी चाहिए। तो फॉर 4 कंटिन्यूअस डेज उनके 200 इंजीनियर को 50-50 के बैच में अलग अलग जिलों में भारतीय मानक ब्यूरो के अधिकारियों ने, बाहर से हमने एक्सपर्ट्स बुलाए थे, उनको पूरे दिन की केबल्स के ऊपर और केबल टर्मिनेशंस जो भी चैलेंजेस होते हैं उनको एड्रेस करने की अभी 5 तारीख, 7 तारीख, 8 तारीख, 9 तारीख को हमने 4 दिन उनको ट्रेनिंग प्रोवाइड की, सेफ से सुनिश्चित करने के लिए यहाँ का जो है क्वालिटी इकोसिस्टम रोबस्ट रहे और मानकों के अनुरूप ही सारे एप्लीकेशंस यूज़ किए जाएं। तो BIS के बैकग्राउंड के बारे में तो मैंने आपसे चर्चा कर ही ली। दिस इज़ अवर प्रेजेंस। हम लगभग हर राज्य में उपस्थित हैं। गुजरात में तो हम 4 जगह उपस्थित हैं क्योंकि यहाँ पे इतने ज़्यादा लाइसेंसेस है, इतनी ज़्यादा इंडस्ट्री है। वी आर एट अहमदाबाद, वी आर एट राजकोट, एंड फ्रॉम राजकोट ओनली वी हैव अनदर ऑफिस फॉर गांधीधाम, देन वी हैव अनदर ऑफिस एट सूरत। और स्टैंडर्डाइजेशन की जो हम बात करते हैं, मानक जो बनाते हैं, मानक बेसिकली भारतीय मानक ब्यूरो अकेले मानक नहीं बनाता है। भारतीय मानक ब्यूरो के विभिन्न टेक्निकल डिविजनल काउंसिल्स हैं, ये 17 डिविजनल काउंसिल्स है आज की तारीख में। इनमें से एक इलेक्ट्रो टेक्निकल डिवीजन काउंसिल है, उसके तहत विभिन्न टेक्निकल कमेटीज़ हैं और उनमें अलग अलग स्टेक होल्डर रिप्रेजेंट करते हैं, इंडस्ट्री से रहते हैं। यहीं पे कई रिप्रेजेंटेटिव तिवारी जी बैठे हैं, KEI से भी होंगे। और तो हम बड़े, जब भी कहीं जाते हैं किसी कार्यक्रम में, बड़े निश्चिंत रहते हैं कि अगर कोई सवाल होगा तो हम बड़ी आसानी से किसी और को जिम्मा उसका सौंप सकते हैं, क्योंकि हम कहते हैं साहब जो भी है अच्छा है बुरा, उसमें ये हमारे भागीदार हैं ये। तो नहीं, दे हैव बीन कंट्रीब्यूटिंग अ लॉट। और इनफैक्ट रबर और इलास्टोमर केबल्स में तो दे हैव बीन पायनियर्स। और जो 9968 के जो पार्ट 1, 2 और 3 हैं, उसमें इनका सबसे ज़्यादा योगदान है उस मानक को बनाने में। हम लोगों ने काफ़ी समय, मैं दिल्ली में था, हमने काफ़ी समय साथ में काम किया है। और सो ETD में देयर आर 47 कमेटीज़ अलग। इसमें एक ETD 09 कमेटी है जो पावर केबल्स की सेक्शनल कमेटी है, और उसमें 114 स्टैंडर्ड्स अभी पब्लिश हो चुके हैं, जिसमें से कई स्टैंडर्ड्स आप में से ज़्यादातर लोग उनको अभी यूज़ कर रहे होंगे। और कुछ जो नए स्टैंडर्ड्स हैं, जहाँ पे जब रिन्यूएबल की बात करें, क्लीन एनर्जी की बात करें, एक नया स्टैंडर्ड है 17293। ये जो PV एप्लीकेशन जो सोलर पावर प्लांट्स, बेसिकली पहले तो कोई कहीं 694 कोई लगा दे रहा था, कोई 7098 लगा दे रहा था, लेकिन फिर जो इंटरनेशनल प्रैक्टिसेस को अडॉप्ट करते हुए, आत्मसात करते हुए एक मानक बनाया गया है। और अभी MNRE ने भी इसको नोटिफाई किया है। तो अब जहाँ पे भी PV एप्लीकेशन हो, और तो 1500 वोल्ट DC तक यही मानक प्रयुक्त किया जा रहा है। देन 7098 पार्ट 1, पार्ट 2 और पार्ट 3 से आप लोग भली भांति वाकिफ होंगे। ये जो करस्पॉन्डिंग इंटरनेशनल स्टैंडर्ड्स हैं, उन्हीं पे आधारित स्टैंडर्ड हैं। और इसमें जो पार्ट 3 है, इसको अभी रिवीजन भी इसका लिया गया है। ये पार्ट 1 भी रिवाइज हो गया है, पार्ट 2 भी ऑलमोस्ट रिवाइज है, और पार्ट 3 भी फाइनल होकर प्रिंट में आया है। उसके आगे मैं चर्चा करूँगा इसके बारे में। ये जो 7098 पार्ट 3 का मैंने बताया, जो 22546 है, और इसमें अभी हमने 33 kV से लेकर 400 kV तक, पहले हम 220 kV तक बात करते थे। नाउ दिस स्टैंडर्ड टॉक्स अबाउट रेटिंग्स अप टू 400 kV। और ये IEC 60840 और IEC 62607, 150 kV तक 840, उसके आगे का 62607 के आधार पे ये मानक की संरचना की गई है। इसमें ज़्यादातर इंटरनेशनल बेस्ट प्रैक्टिसेस को अडॉप्ट किया गया है, लेकिन साथ में जब मानक बनाया जाता है तो हमारे एक्सपर्ट ये सुनिश्चित करते हैं कि इंडियन कंडीशंस को भी यथासंभव, जैसे कहीं पे होता है एम्बियंट कंडीशंस उनकी अलग है, हमारी अलग है, तो वो अगर 45 की बात करेंगे तो 50 कर देंगे, वहाँ पे 90 की करेंगे तो हम उसे 95 करेंगे। अपनी कंडीशंस को ध्यान में रखते हुए, जहाँ पे कहीं हॉट एंड ह्यूमिड होगा तो वहाँ पे टेम्परेचर के ही बढ़ाएंगे, मॉइस्चर के लिए हम अलग से कहीं ना कोई रिक्वायरमेंट डाल देंगे। कोई भी इंटरनेशनल स्टैंडर्ड आज की तारीख में बनता है, जो उसकी करस्पॉन्डिंग IEC कमेटी है, उसमें भी हमारे जो मेंबर्स हैं वहाँ पे पार्टिसिपेट करते हैं। BIS is founder member in all the 3 international standardization platforms including IEC, ISO और ITU. इलेक्ट्रोटेक्नोलॉजी में IEC है, तो IEC में ज़्यादातर कमेटीज़ में वी आर वेरी प्रोएक्टिवली इन्वॉल्व इंक्लूडिंग द केबल्स कमेटी, और वहाँ पे हम ITD 09 के मेंबर्स हैं जो ये सुनिश्चित करते हैं कि जब आप कोई इंटरनेशनल स्टैंडर्ड को अडॉप्ट करते हैं बनते समय वो सारे मेंबर्स को वोटिंग के लिए भेजा जाता है, तो सब मेंबर्स को हम अवगत कराते हैं, और बनते समय भी अब आज की तारीख में उसमें एक नेशनल डिफरेंसेस को रिकॉर्ड करने का एक प्रावधान आ गया है। तो अगर वो इंटरनेशनल स्टैंडर्ड बनते हैं तो नेशनल डिफरेंसेस वहाँ पे वो पीछे कोट कर सकते हैं कि इंडिया का ये कहना है कि यहाँ पे इस रिक्वायरमेंट को इंडिया के परिप्रेक्ष्य में इस रूप में पढ़ा जाए। तो अगर हम कल को उसको स्टैंडर्ड को अडॉप्ट करते हैं एज बीइंग अ सिग्नेटरी टू WTO TBT एग्रीमेंट, तो वहाँ पे हमारे जो रिक्वायरमेंट है वो ऑलरेडी एज अ नेशनल डिफरेंस वहाँ पे रिकॉग्नाइज कर लिए गए हैं। और उसके अलावा कई बार ऐसा होता है कि स्टैंडर्ड बन गया उसके बाद हमारे सामने आए तो हमारे पास भी प्रावधान, कई हमने ऐसे मानक है जो अडॉप्ट किए हैं और उसमें आखिर में हम एक नेशनल डिफरेंस का एक नेशनल एनेक्शर डाल देते हैं कि ये स्टैंडर्ड तो हमने अडॉप्ट कर लिया है, लेकिन इस पर्टिकुलर क्लॉज में या तो ये हमारे यहाँ एप्लीकेबल नहीं, या एप्लीकेबल है तो यहाँ पे टेम्परेचर ये नहीं ये पढ़ा जाए, और साथ में उसका कारण भी एज अ नेशनल कमेटी हम उसमें रिकॉर्ड करते हैं। तो जो हार्मोनाइजेशन की कई बार बात होती है, तो कई लोग प्रोस में बात करते हैं, कॉन्स में बात करते हैं, तो उसको एड्रेस करने का जो तरीका ये हमारे यहाँ निकाला गया, इंटरनेशनली एक्सेप्टेड नॉर्म है ये, और ये सब हमारे कमेटी के मेंबर्स ये सुनिश्चित करते हैं कि वो नेशनल डिफरेंसेस या नेशनल एनेक्शर्स अडॉप्ट करते समय उनको ध्यान में रखा जाए। देन ये कुछ और जो नए स्टैंडर्ड हैं जैसे 14255 एक काफ़ी यूज़ हो रहा है, जो एरियल बंच केबल होती है, जो डिस्ट्रीब्यूशन में पहले लोग कहते थे कटिया डाल दिया, तो उसे बचाने के लिए एक ये केबल आया था, हकीकत यही है। और उसके बाद काफ़ी यूज़ हुआ, होते होते हुआ कि स्टैंडर्ड तो हमारा 1100 वोल्ट तक रह गया, लेकिन आप लोग काफ़ी आगे बढ़ गए, तो आप लोग 11 kV और 33 kV भी आप एरियल बंच में चले गए। तो BIS जो की चूँकि नेशनल स्टैंडर्ड्स बॉडी है तो ये सुनिश्चित करेगा कि आप कोई भी प्रोडक्ट बनाए तो उसका स्टैंडर्ड भी रहे, ऐसा ना हो कि नॉन स्टैंडर्ड रहे, अपने अपने हिसाब से आप लोग रिक्वायरमेंट, तो उसका भी एक स्टैंडर्ड बन गया है, भी उसके बारे में आगे बताऊंगा मैं। सो ये 1554 भी एक बहुत वाइडली यूज PVC हैवी ड्यूटी केबल्स जो है वो भी रिवीजन में अभी चल रहा है उसमें। ये कुछ प्री ड्राफ्ट है, जब कई बार हमसे कहा जाता है कि भाई अगले 10 साल में आपका क्या विज़न है, तो हकीकत मानिए हमारा 10 साल में ये विज़न है कि जो भी जितने भी स्टेक होल्डर्स हैं उनके जो भी रिक्वायरमेंट आएंगे, जो भी मानकीकरण अपेक्षाएं आनी है, आवश्यकताएं, उनको हमें एड्रेस करना है। तो आप कुछ भी नया बनाएंगे तो हमें सुनिश्चित करना है कि उसका स्टैंडर्ड हो। तो आपका विज़न जो अगले 10 साल में है उस विज़न के स्टैंडर्डाइजेशन एस्पेक्ट को एड्रेस करना हमारा विज़न है ये। तो वो हम ये सुनिश्चित करते हैं, क्योंकि 10 साल आगे की टेक्नोलॉजीज़ एज अ स्टैंडर्डाइजेशन बॉडी हम नहीं विजुलाइज कर सकते हैं, लेकिन एज अ मैन्युफैक्चरर, एज अ कंज्यूमर, कई बार कंज्यूमर के इंटरेस्ट होते हैं, कई बार मैन्युफैक्चरर नई टेक्नोलॉजीज आती हैं उनको बनाते हैं। जब भी कोई प्रोडक्ट आएगा तो उसके स्टैंडर्डाइजेशन एस्पेक्ट्स को एड्रेस करना वो हमारा धर्म है। तो जो मैंने बताया ये एरियल बंच केबल्स फॉर वर्किंग वोल्टेज, अब तो आप लोग जो कई जगह कई लोग आप लोग खरीद रहे थे प्रोडक्ट, जो एरियल बंच केबल 33 kV तक आप अलग अलग कोई XLP या जो भी कन्फिग्रेशंस बना रहे थे, अब वो सारे इस स्टैंडर्ड, दिस स्टैंडर्ड इज अंडर डेवलपमेंट, आप ही सब मिलके बना रहे हैं इसको। और एक नया स्टैंडर्ड है जो हमारा जो 10810, आप कोई भी मानक आप केबल से रिलेटेड यूज़ करते हैं तो उसमें टेस्टिंग मेथड के लिए हमारी IS 10810 सीरीज़ है, उसके अलग अलग पार्ट्स हैं, आप सब लोग रेफ़र कर रहे हैं, सब लोग यूज़ कर रहे हैं। एक नया स्टैंडर्ड उसमें बनाया है कि अब हम प्रोडक्ट्स की, जब अगर केबल जल रहा है, कई बार होता है कि केबल जला तो उससे बोले धुएं से लोग मर रहे हैं, तो उसमें टॉक्सिसिटी इंडेक्स का एक प्रावधान लाया है कि नया स्टैंडर्ड डेवलप हो रहा है। ये आप सभी स्टेक होल्डर्स के काफ़ी इंटरेस्ट का सब्जेक्ट है ये कुछ ऐसे जैसे एक इंस्ट्रूमेंटेशन और कंट्रोल केबल्स के लिए एक नया स्टैंडर्ड हम लेके आ रहे हैं, और EV चार्जिंग के लिए भी जो EV चार्जिंग प्रोटोकॉल्स आ रहे हैं, तो उसकी EV चार्जिंग के लिए पहले अभी तक आप लोग एक 2465 करके ऑटोमोबाइल केबल का आप यूज़ कर रहे हैं स्टैंडर्ड, ये स्टैंडर्ड ये सुनिश्चित करेगा कि सारे EV चार्जिंग से रिलेटेड जो भी आपके केबल्स के रिक्वायरमेंट है उसको ये एड्रेस करेंगे। एक कई जैसे 694 में ही कई लोगों ने स्क्रीन डालते थे तो उसका बोले उसका केबल नहीं है, तो स्क्रीन केबल्स के भी एक ये स्टैंडर्ड आ गया है। और 17505 काफ़ी कई मैन्युफैक्चरर्स आगे आ गए हैं जिन्होंने लाइसेंस इसके लिए ले लिया है। ज़्यादा से ज़्यादा लोग अब इसको फायर सर्वाइवल केबल्स ये करके यूज़ कर रहे हैं, जो पहले एक BS हुआ करता था, तो अब इंडिया ने ये सुनिश्चित किया कि वी हैव अ स्टैंडर्ड फॉर दिस। एरियल बंच का मैंने आपको बताया। एक ये यहाँ एक नया स्टैंडर्ड है 18833, इसको वी हैव अडॉप्टेड एज आइडेंटिकल IEC 62895, इट्स अ वेरी क्रिटिकल स्टैंडर्ड। ये 320 केवी तक के आपके जो HVDC केबल्स है एक्सट्रूजन से वो जो बन रहे हैं उनको ये एड्रेस करता है। ये कई शायद स्टेक होल्डर्स का सवाल भी था ये। तो इसके जो की फीचर्स है उसमें अलग अलग टेस्ट मेथड सब उसमें प्रावधान दिए गए, इंक्लूडिंग ये जो आपका 18833 नया स्टैंडर्ड जो 7098 बन रहे हैं, या फॉर दैट मैटर कोई भी केबल के स्टैंडर्ड नए बन रहे हैं, उसमें सुनिश्चित किया जाता है कि जो उनके ज्वाइंट्स और टर्मिनेशंस या जो भी एसेसरीज के आज की तारीख में वो सभी उसी स्टैंडर्ड के अंदर टेस्ट मेथड सब हम प्रोवाइड वहाँ करा रहे हैं। और ये लास्ट माइल डिस्ट्रीब्यूशन के कई केबल्स हैं जो पहले से यूज़ कर रहे हैं। 694 है, घर घर में यूज़ होता है ये। 1554 की जो सीरीज़ है, वेल्डिंग केबल्स 9857, 9968 यूनिवर्सल केबल्स के फ्लैगशिप प्रोडक्ट है। और ये HFFR केबल्स जो बहुत आज की तारीख में 694 का सब्सटीट्यूट है, 17048 जो 1100 वोल्ट तक हेलोजन फ्री फ्लेम रिटार्डेंट केबल है। कई इसके मैन्युफैक्चरर्स आगे बढ़ के दे ऑलरेडी टेकन लाइसेंस। तो ये एक छोटा एक ग्लिम्स था। इसके अलावा बस इतना कहूँगा कि भारत एक अकेला देश है जहाँ पे हमने सुनिश्चित किया है कि जो स्टैंडर्ड्स आर अवेलेबल फ्री ऑफ कॉस्ट। बाकी सब जगह स्टैंडर्ड्स आर प्राइस पब्लिकेशंस। हमने कैलकुलेट किया कि पूरे साल भर में कितने के स्टैंडर्ड बनते हैं, वो कैलकुलेट करने में सरकार ने निर्णय लिया कि हम इसको फ्री ऑफ आप सिंपली आप BIS की वेबसाइट पे जाएं, वहाँ पे अपना यूज़र नेम पासवर्ड आप रजिस्टर करें, जितने स्टैंडर्ड्स आपको ज़रूरत है आप वहाँ डाउनलोड करिए, आपके नाम के साथ वो डाउनलोड हो जाएंगे, ताकि कल को कोई ये भी नहीं कह सकता है कि अनऑथराइज कॉपी आप यूज़ कर रहे हैं। तो प्लीज़ यूज़ दीज इंडियन स्टैंडर्ड्स, उनको डाउनलोड करें। और वहीं पे जब आप डाउनलोड कर रहे हो कि वहाँ पे एक और ऑप्शन आता है कमेंट ऑन द स्टैंडर्ड। तो पहले होता था ना कि साहब स्टैंडर्ड दिल्ली मनते, तो ऐसा नहीं है। आप अपने कंप्यूटर पे बैठ के वहीं के वहीं आप वो कमेंट वहाँ पे दे सकते हैं और उसको कमेटी के द्वारा टिकअप किया जाए। तो एक बार फिर बहुत बहुत धन्यवाद और बहुत बहुत बधाई के पात्र हैं जो ऑर्गेनाइजिंग इंस्टीट्यूशन।
Thank you very much, Sumit sir has really make interest, right? So BIS and other things. So if you have any regarding BIS, how it is formulations, how many people are involving in it, and so on, right? So if question quickly ask the question to the speaker, otherwise we can move forward.
सर लाइसेंस हम देने वाले हैं।
Sir, thanks for a good presentation. Just we request you, since BIS is standard IES 1255, that is for the installation of the cables only up to 33 kV. Since more and more EHV cables has to be installed in India and we are installing every day, so just we request you prepare a standard for the laying of the cables up to 400 kV separately.
ये नोट कर लें, कल हम मेल भेज देंगे, बिल्कुल निश्चित। टुमारो आपका ऊपर चला जाए। ड्राफ्ट है क्या उसका? मुझे ऐसा लग रहा है 25 का मैंने अभी, हाँ उसका है।
1255 का पार्ट 2 up to 400 kV there is a draft.
मैंने शुरू में ही कहा था, I had a disclaimer कि मेरा कॉन्फिडेंस रहता है मेरे आसपास में, they are there. So बहुत बहुत हाँ मैडम वहाँ से
Please, yes.
हाँ मैडम, केबल का फेलियर होता है, मैं नहीं समझा।
Once cable gets fault, how can we identify it? I think, am I right?
IES के
अच्छा टेस्ट के तो उसमें तीनों उसमें तो सब प्रोटोकॉल दिए हुए हैं ऑलरेडी। आजकल जितने भी स्टैंडर्ड्स बन रहे हैं तीनों उसमें प्रोटोकॉल दिए रहते हैं कि एग्जैक्टली उसमें आज की तारीख में जितने भी स्टैंडर्ड्स बन रहे हैं उस सब में सैंपल साइज दिया जाता है। साथ में कई बार जो हमारी स्कीम ऑफ इंस्पेक्शन और टेस्टिंग है वो ये वहाँ पे मेंशन होता है कि अगर आपका टेस्टिंग के समय सैंपल फेल हुआ तो फिर आपको क्या क्या बढ़ाना है और कितने और दोबारा चेक करने हैं। अच्छा
फेलियर हुआ उसका स्टैंडर्ड मेथड
अभी लेइंग का भी एक स्टैंडर्ड बन रहा है, वो अभी हाँ कल मैंने वो देखा है, लेइंग का भी जो है ना इंस्टॉलेशन और लेइंग का एक बहुत खूबसूरत स्टैंडर्ड बन रहा है। तो मैडम मैं आपसे भी रिक्वेस्ट करूंगा कि आप भी उसमें ऑनलाइन जुड़िए और उस स्टैंडर्ड में आप कंट्रीब्यूट करके, पहले भी अपने कुछ आपने बहुत अच्छे वैलिड पॉइंट्स दिए थे, प्लीज़ पार्टिसिपेट इन द स्टैंडर्ड फॉर्मुलेशन। उसमें एक डॉक्यूमेंट इज देयर, तो एक बार उसे पढ़िए, उसमें प्लीज़ कमेंट कीजिए।
और उसमें ये फेल होने के बाद हमारा OEM के साथ इतना ही सैंपल लेना है, उतना ही लेना है, उसके बाद इतने ही टेस्ट करने हैं, इतने नहीं करने हैं, तो वो भी स्पेसिफाई कर लीजिए।
अब ये थोड़ा ये मैडम ये कई बार ना क्या होता है कि ये कॉमर्शियल एस्पेक्ट आ जाता है इसमें, तो उसमें हाँ तो स्टैंडर्ड्स ये कहते हैं कि स्टैंडर्ड कॉमर्शियल एस्पेक्ट्स को एड्रेस नहीं करते। कई बार भाई ये कुछ चीज़ें जैसे स्टैंडर्ड्स है, तो स्टैंडर्ड्स में देयर आर रिक्वायरमेंट्स स्टिपुलेटेड, लेकिन उससे आगे बढ़ के कोई भी बायर को रिक्वायरमेंट अपनी मांगने का अधिकार है। तो हम कभी किसी बायर को ये नहीं कह सकते कि आप इससे ज़्यादा मत मांगो। कम मांगेगा तो अगर मैंडेटरी हो तो कह सकते हैं कि भाई आपको मिनिमम तो आपको इंडियन स्टैंडर्ड मांगना ही मांगना है, ये उससे ज़्यादा वो बायर मांग सकता है। अब उसके अगर कसौटी पे खरा नहीं उतर रहा है तो अगर स्टैंडर्ड के हिसाब से हम तो हैं वहाँ पे एड्रेस करने के लिए, लेकिन उसके अलावा उसका कोई रिक्वायरमेंट था और मैन्युफैक्चरर को चूकी तो वो तो फिर बायर और सेलर के बीच की बात है। तो उसमें इट वुड नॉट बी अप्रोप्रिएट फॉर एनी एजेंसी टू सर।
यस।
सर अभी आपने बताया कि वो प्लस माइनस 320 केवी एचवीडीसी के लिए भी आईएस फॉर्म हो गया है, तो किसी मैन्युफैक्चरर ने अभी तक अप्लाई किया है फॉर दिस बिहाइंड?
अभी नहीं। और इनफैक्ट एचवीडीसी में तो पावर ग्रिड काफ़ी आगे बढ़ के हमारे साथ है। इनफैक्ट एचवीडीसी या यूएचवीएसी वो स्टैंडर्ड्स कमेटी जो बनी है वो पीजीसीआई लगातार हमारे साथ जुड़ा हुआ है। मुझे लग ही रहा था। तो आप ये वहाँ पे दे रहे हैं, इंटरनेशनल कमेटीज़ में भी इनको हम भेजते हैं, वहाँ पे अपनी बात ये बोलते हैं। वेरी गुड।
Very much. Now I request Professor Swarup sir from IIT Madras to give his presentation. Swarup sir.
Okay. Good afternoon, everyone. You must be wondering what is an academician doing with industries. You can see I am sandwiched between 3 industry personnel before and 3 industry personnel after. See, academic people, they profess knowledge and they disseminate knowledge. My presence here is to disseminate knowledge, okay, to teach what we know and learn what we know from industries. So this presentation shows how we do. Everyone talks about offshore wind transmission, but there are many things before that. Okay, this is how a typical diagram. Okay, you have sea and land. You have wind turbines in Gujarat and some wind turbines in Tamil Nadu. You have converters, substation, of course power grid person has shown in detail. From an academic perspective, when we teach the students, okay, we make them work, we make them calculate, we make them simulate so that they can have a real feel of what the system is. You can see here, this is the sea, this is the land, and also there is Gujarat and Tamil Nadu. This is an academic exercise. I repeat, an academic exercise between different universities, one in Denmark, one in Australia, because they want us academic institute to perform some studies, create manpower, bring awareness to students. What is required? You see here there is wind power generation, there is power converter from DC to AC, AC to DC, transformer, substation and everything. What next? What is the challenge in this from an academic perspective? So this is the diagram shown by a power grid person. This is a potential of wind power farms. We know there is wind farm, but how do you know? Wind is uncertainty, there is a lot of randomness. Can you translate this uncertainty into certainty? Can you say this block amount of power is available so that the power state load dispatch centers can say I can rely on this amount of power. This is what we do. We try to do mathematical methods, how to transform uncertainty to certainty and say this amount of power is available for the next 5 years. This is what we do. We need to perform wind power forecasting and generation. These are the various methods how to do wind power forecasting. How much is the wind power generation? Lot of uncertainty is there. Can you tell with certain certainty how much is the wind? You can see here the blue line shows the variability. Okay, and As everyone knows, AI is gaining more importance, neural networks. So we use different machine learning models. Why machine learning models? There's a lot of uncertainty. When a lot of uncertainty is there, you can't use deterministic models. Regression models are widely used, time series, you can't use any of them. You need different data-driven methods. So this is how we try to do the forecasting of wind power availability and wind power generation. Next is the transmission. This is how subsea marine transmission cables, they use HVDC and HVAC, HVDC submarine cables, and open access transmission. And the fourth one is mostly submarine cables, they transfer both the power and the data. Internet cables are submarine cables. Cyber attacks are quite common. You might have heard about the Ukrainian cable, many cyber attacks occurred. Okay. How do you do studies? We need SCADA systems. In fact, we want to show some of the studies we have done on cyber security of cables. An Australian government came to us and said, okay, India, Australia, there's a lot of potential for cables, a lot of cyber attacks. How do you detect? Which techniques do you use? People use pattern recognition techniques, multi-resolution analysis, many methods are widely used. And now, with this wind power availability, I'm talking about 10 years ahead or 20 years ahead, I have a lot of wind power available. We did this study for MNRE. They asked us to see how much wind potential is there. Can we buy and sell wind power markets? How much power you can sell? How much gigawatts you can sell? Are there any wind power markets? This is what we did. There is day-ahead markets, renewable energy markets, and green day-ahead markets. This is called electricity energy trading. This is what we teach our students. Wind energy, even that is there, how do you sell and buy power? Here it is only buying power from markets and selling it to the grids. These are some of the things we have done. Next is policy. This is a very important issue related to standards. Even though we have the technology, some of the policies prevent us from going ahead. Even though we have the technology ahead, policies don't prevent from us ahead. For example, in Tamil Nadu, we have some policies which prevent us from laying out cables along the shore. You know why? Technology is ready. Because in the Tamil Nadu shore we have turtles which come. That is a natural habitat. There was opposition saying that don't lay cables around the shore. All the technology has collapsed in front of societal problems. So we have to convince them, we have to look for an alternative route where we can lay cables. This is what the policy is important. Many people are ignoring the policies, the societal benefits. Even in Tamil Nadu coast we have fishermen. They also opposed. Our livelihood is lost if you put cables. We can't go for fishing. So in IIT Madras we have an energy consortium group which addresses all these issues. Societal issues, technological issues and policy issues. I'm a part of that energy consortium. I'm in the electrical department, but I work with all departments including ocean engineering. Okay? This is very important. Policies are very, very important. This is just to show, and this is the work we did with University of Sydney. They developed policies. They are convincing the Tamil Nadu government that it is safe to use cables. So we work with humanities department. The engineering is not just calculations. We have to work with management, humanities, etc. Any questions? I made it very short so that it want to be more interactive. Thank you.
hello, how the offer can be harvested and so on. If any from audience, please. Okay, sir. Thank you. Thank you very much. Now, now I request Tiwari sir from Universal Cable Private Limited to share his thought on how to energy from offshore wind turbine.
Yeah, I know.
Mirror screen is there.
Huh?
Mirror screen is there. And forward reverse and laser.
This
Forward,
part.
reverse, and laser.
Okay. So, good afternoon to everyone. My name is Yogendra Tiwari. I am head technical at Universal Cables. And thank you, JETCO, for giving this opportunity to give our thought about cables, our experience about cables. And with me, we have Mr. Kamlesh Goswami, my colleague. He is regional head for Gujarat. So, we have discussed about this power generation and all renewable. The power, whatever power is generated, that has to be transmitted also. And Rao Saab has already given a comparison where cable is viable, where overhead can be done. So I would basically talk about extra high voltage cable and also touch upon type of submarine cables and what are the limitations as of now in context to India. So this is the index. I would cover basically construction of cables, some reliability, and about submarine, what is the status as of now in India, and what is the cable construction. So typically extra high voltage cable in India, there is no clear definition, but cable of 66 kV up to 400 kV, we normally call them at extra high voltage cables. Extra high voltage cables are mostly single core cable because insulation thickness is high. It's very difficult to make 3-core cables, and even if you are making, the length will be very short. So this is the basic construction. There will be a conductor. Conductor normally say 66 kV, the lowest conductor cross section is 95 square millimeter, and it can go up to 2500 square millimeter. That is the current situation now. IC covers up to 3500 square millimeter, but in India, as of now, the maximum requirement is up to 2500 square millimeter. Conductor can be compacted, conductor can be segmental, and extra high voltage cable, many times conductor is watertight also. That is the requirement. Voltage gauge, as I said, 66 kV to 200 kV, 66 kV, 110 kV, 132 kV, 220 kV, and 400 kV. These are the voltage grades within extra high voltage cable. Insulation, extra high voltage cable is only XLP insulated as of now. Earlier it was oil filled cable, laminar insulation, but as of now it is XLP cable only. This is triple extrusion process. This is completely closed process. There are different curing lines where this XLP extrusion is done. That will come into next slide. And the difference with as compared to medium voltage cable is that extra high voltage cable will definitely have some kind of radial moisture barrier, either lead sheath or aluminum sheath or polyaluminum laminate sheath, and then there will be outer sheath. And so this is the construction basically. You can see the upper construction is lead sheath plus copper skin. In between the copper skin plus aluminum laminate. The third one is corrugated aluminum sheath, and the fourth one is smooth aluminum sheath. Conductor cross section, there is no clear definition, but the lowest conductor cross section are like this. For 66 kV, normally 95 square millimeter. For 110 kV, 150. 132 kV, 185 square millimeter. 220, 400, and 400 kV, 630 square millimeter. But even if any specific requirement is there, manufacturer can be approached, and definitely they will give the solution. Here in what we can see, since conductor cross section is very high, because we are talking about bulk power transmission. So normally conductor up to 1000 square millimeter is usually round compacted conductor. Beyond that, it is segmental conductor, because to avoid that skin effect losses. And sometimes it can be enameled copper conductor also, which can give better current rating more than that of segmental conductor. So normally enameled conductor are used 1600 square millimeter and above. That is the usual criteria. And since we are talking about reliability also, so the whatever cables are made, they have to be reliable. So there should be some check whether so there is provision for providing integration of optical fiber within the cable for temperature sensing like DTS, which can give the sensing of hot spot if there is hot spot is having. So one can monitor and they can take the action. DAS, distributed acoustic sensing, and DSS, distributed temperature sensing. Suppose somewhere some digging is happening and if DAS system is installed, we can possibly, user will come to know that some activity is happening near the cable, so that they can take precaution and prevent the cable from damage. The insulation is XLP insulation, as I said. So there are triple layer insulation, and that it is same for even medium voltage cable. Medium voltage cable 6.6 kV and above, it is always triple layer extrusion. So just for reference, the right side you can see the upper one is XLP granule, and the lower side is semiconducting material. And if you see the triple slice, you can see the three layer. Inner layer is conductor screening, the transparent layer in between is XLP, and outer layer is insulation screening. Purpose of screening is basically to have uniform electrical stress distribution over the conductor and over the insulation also. These are the extrusion process. XLP process is completely closed process. There are three types of lines. Then one is vertical continuous vulcanization line, one is CCV, and other is MDC, Mitsubishi Density continuous vulcanization line. The third one is mostly obsolete now. Very few manufacturers are having. So these two lines are prevalent for manufacturing of medium voltage and extra high voltage cables. Even for we are talking about HVDC and submarine cable, the insulation process will be same. We are talking about reliability. What should we do for reliable insulation? When we are doing insulation in a closed process, the insulation should be void free. It should be minimum moisture content. So in the CCV line or VCV line, it is completely dry cure process where there is curing is by radiant heating, and that curing tube is filled with nitrogen with a pressure of say 10 to 11 bars, so that there is no void formation, and it's completely dry cure process. Then insulation should be contamination free. So first we are taking that handling of insulation, there should not be any contamination during handling process. And for that, normally the feeding system is gravity feeding, so that you need not to apply any vacuum which can give any kind of dust particle or anything. And triple layer extrusion, of course, give the perfect boundaries, so that there are no chances of any void or dust particle in between. So insulation is intact, so that will ensure your reliable insulation. What are the factors need to be considered while designing the cable? So we need to know all those things, whether what is the type of where the cable is to be used, whether indoor or outdoor, whether underground or in the duct installation. Of course, earth system normally EHV earth system only, so that is not very big issue. And then we need to understand what is the load we are going to transfer from cable, and what is the short circuit rating. So based on that, the conductor cross section has to be designed. Whether there is any provision for future increase of load also. So all these things have to be taken into account. Suppose operational condition and environmental condition also need to know, so the cable is designed accordingly. Sir, Madam was talking about this reliability and testing part. These are the tests which are normally carried out for extra high voltage cable. This is pre-qualification test, that is 1 year long duration test, that is done for 220 kV and above. Basically, this is to demonstrate long duration test, and this test is done on cable system. This is 1 year for heating cooling cycle, and 70% at higher voltage throughout the heating cooling period, and then after that it is tested for lightning impulse. So this gives satisfaction and kind of safety of life that your cable system will last for a long time. Then there is type test. Type test is basically validation of design, and the system, your system will perform as per requirement. So for 220 kV type test is also on cable system, not cable alone. Then there is routine test. Each and every manufacturer length is tested for high voltage, partial discharge test, of course conductor resistance test. So this is responsibility of manufacturer that each and every length is manufactured has to be tested for routine test. Then there are sample tests. They are also for demonstrating that cable are meeting the intended requirement, and that is done on sampling basis. Normally, sampling is on 10% of the drum as per IC specification. And then there are site tests, installation tests after commissioning that. Suppose you are doing this DC test on sheet, then sometimes soak test, sometimes AC voltage test after installation of accessories. And once everything is fine, then you can say that your installation is complete, joint installation has been perfectly all right, then you can rely on that cable system. One more thing in extra high voltage cable, since being single core cable, this is very common phenomena. When we are transmitting power through a conductor, there will be voltage induction in the screen, and since cable copper screen, or let's say the cross section is very high, so suppose we are earthing, anyway earthing has to be done the metallic screen. If we are not doing the earthing, there will be floating voltage on the insulation screen, that will damage the screen. So at least one end it has to be earthed. So suppose we are doing the earthing at both ends, what will happen? There will be circulating current in the screen, and then we will heat up the cable. So we will not get there will be heating, and then we will not get complete current rating. I mean, current rating reduction will be there. So how to mitigate that? There are different methods of sheath bonding to take care of this. One is first that both end bonding. If we earth the screen at both ends, there will be circulating current. Here current rating will be less, but there will be continuous circulating current losses. Suppose we have to avoid that circulating current losses, get some more current rating, then there is another method, single point bonding. Single point bonding basically for a smaller route. We can earth the screen at one end, but other end it has to be earthed through a sheath voltage limiter, or we call it sheath voltage, or you can call it small surge arrestor. So what will happen in the at the open end, there will be some voltage, and if there are some transient and all, that transient surge limiters are basically non-linear resistors. So they will, in case of higher transient voltage, they will allow the voltage to pass, and then they will restore. So in that case, normal course, there will be no circulating current, but there you have to lay one earth continuity conductor connecting the both the earthing points. Suppose route length is long, where single point bonding cannot be done. Then this is the third method, cross bonding method. This can be used for longer length. Here a major section is divided. Okay. So this is very common. I mean, the engineers must be having it. I will just talk about submarine cable. Submarine cable, AC or DC. Normally, AC cable, DC cable have certain advantage because there will be no losses, and you can use two cables only. This last difference is there. Here you can see there are only two phases, so loss will be lower here. There will be no sheath loss, there will be no armor losses in DC cables. This is typical current. This is typical design of single core AC cable. Normally like AC only, but there will be lead sheath, and the outer serving will be normally polypropylene bitumen coating, and armor has to be special depending upon the depth of laying to take care of the tension. This is 3-core cable. Here optical fiber provision is also there. Here also construction like AC cable, but armor is special and outer serving is special. These are tests like any other cable, but here some mechanical tests are included for armor. This is DC cable construction again like AC cable, but here insulation is different from AC because XLP is not safe. For DC, I mean special insulation is there, which is because there is difference between AC and DC cable in terms of stress distribution. AC cable is basically based on AC insulation is based on permittivity, while the DC insulation is dependent on type of resistivity and resistivity control. So this is construction, and these are the standard reference. Basically, I wanted to come to this slide. I mean, AC land cable up to 400 kV, we have all the facilities here. Manufacturing technology is there, testing facility is there, third party validation is there, and installation experience is also there. But when it comes to submarine cable, India, I think there is hardly any experience as of now. Manufacturing facility, limited facility is there, but longer length, again, if we have to talk dispatch in turntable and all, so that cannot happen. I mean, cable can be transported by land only. So that issue is there. And land transportation, installation experience is also not there as of now, because now only this requirement has started coming. Earlier there was no requirement also. So this shortcoming is there. Similarly for HVDC land cable, up to 320 kV, some three installations are there. Based on that, specification has been developed. But again, there is technology, manufacturing technology there, but there is some issue. There is no third-party testing validation, neither CPRI nor ERDA. They don't have any testing facility for HVDC. And the other issue is there because there has to be type test and PQ test. So availability of DC accessories is also an issue, because normally the worldwide manufacturer, they are making cable and accessories both. So they are somehow keeping the technology secret. So that is also issue. The same issue is with like AC, DC submarine cable is also there, because we are not there as of now. There is no technology as such. So these are the limitations, but as I hear, when there is big requirement, maybe future one has to think what to do. But as of now, this limitation is there. Thank you, sir. I'm sorry I have taken a long time.
At how to design the cables and so on, then how it is made from different components, what is the importance of different components. I think those who are using the cable, they may be able to understand what are the different parts of the cable, importance of different components, how the design is there and so on. So if any question from audience, please.
ये जो
जी हाँ है ना, अभी काफ़ी सारे जैसे हम लोग सप्लाई करते हैं. वी आर प्रोवाइडिंग दैट फाइबर एंड मेटालिक ट्यूब FIM2, दैट इज वी आर इंसर्टिंग विद इन द कॉपर स्क्रीन.
due to the
There is no voltage, induced induction in optical fiber.
but just we have installed one cable line, then parallel to separate communication.
See, that
Cable agency is said that that cable is laying.
That is correct. Actually, as of now, that is happening. But what is happening, if we have not a correct temperature of the cable, so the fiber has to be close to that component, which suppose we have to restrict the temperature of insulation more than up to 90 degree. So if fiber is very close to that, then we can get to know exact temperature.
It's okay due to not the temperature, but the magnetic field is can affect in the.
No. It's known. Optical fiber, there is no voltage induction. There is no voltage induction, and this is established technology. Cables are already in use.
Okay.
Possibly metallic tube has to be there, but fiber, there is no induction voltage induction fibers.
Okay.
Okay, thank you. Any other?
Hello. Very good afternoon to everyone. This is the question for all the respected presenters. I want to ask that suppose we have laid a transmission line under the sea successfully, and let's say that let any fault occurs in the transmission cable under the sea, and what time it will take for us to rectify the fault, and what time it will take to reconstruct the transmission line. So is it really feasible for us that it can be used as a primary transmission line, or we have to provide any alternate transmission line, and can it be used as a primary source to any substation or any island or any place?
I think I would request sir to reply this question, because he has expertise in submarine cable installation.
Sorry, I think I am the knowledgeable person about this. You see, the submarine cables, what are the possibilities? Where do we connect? There are three scenarios. One is from mainland to island. Okay, consider Andaman Nicobar is an island to India. So from India, we are connecting a cable to Andaman. That is one. Second thing is one island to another island. If there are cluster of islands nearby, so you have to lay a cable between one island to another island. And third is onshore to offshore. In one of the previous slide you had seen there was an offshore platform, NTPC I think. So these are the three these things. Worldwide, if you see, there are thousands of cables already installed, working excellent. So it can be very well connected as a primary source. You don't need plan B. Now, for the installation of submarine cable, there are three main things. The one is route survey. Before you decide the routing of the cable, you need to do a bathymetric survey. Now, bathymetric is a probably new word people might have not heard, but it's very simple. If you know topography, topography means leveling. कितना ऊपर कितना नीचे किधर curve है किधर deep है. So when you do the same survey below the water, it is called bathymetric survey. So you first thing is bathymetric survey, very proper. Now there are different technologies through which you can do bathymetric survey, but the best is you vehicle. A robot will go below, and high resolution cameras are attached to it. So with high resolution camera, you do the survey. At few locations, you collect the sample also, and you do the geotechnical testing of that soil. Maybe now you see that it looks like a rock, but actually it is very soft. Because of water current, there may form a free span. Free span means what? You have laid the cable, but in section, the land has collapsed. So right now when you lay, you see that cable is supported, but after 3 months, there is no support below. So there will be pressure of weight itself of the cable. Okay. And third thing is cable design. Now this was a background. Now to respond to your question, it typically any cable, subsea cable, if develops the fault, minimum 3 to 4 months will be required. First thing is you will have to identify what is the type of fault. Now what are the reasons of the fault? For example, somebody has done anchoring. So ऊपर से anchor डाला, वो ये ऐसा cable है. This is the actual cable we have installed offshore Saudi Arabia. Okay, so you see how it is very heavy. I'm holding, and it is very, very strong. But if there is a anchoring has been dropped on this, it has got certain power, but it can break. It can break. So if this cable has break, then you have to use the cable jointing kit, and that madam was asking before. So the cable jointing kit is around 7 meters long, and what you need to do, you need to deploy a special vessel along with the submarine cable jointers. So you have to call the manufacturers. Those cable jointers shall be available. They will go, and what they have to do is they have to lift the cable from the seabed, put it on a vessel, and there they have to do the jointing. You can't do jointing in the water. So, sir was asking that availability of the vessels is an issue. It is really an issue. You have to book well in advance. China, South Korea, there are only few nations in the world. Those are having cable laying vessels, dedicated cable laying vessels. They work all around the world. कभी पैसिफिक में, कभी इधर, कभी अटलांटिक में, कभी इंडियन ओशन. वो लोग यही करते हैं. But they are very busy. And typically one vessel, normal medium size capacity, will cost you $1 lakh per day. So idle time is very, very costly. अगर एक भी दिन आपका लेट हुआ, your project costs shoot like anything. So sometimes, so this is the outer sheet, okay, and you will see it is yellow also. And वो सर का जो था ना, उसमें भी yellow color दिखाया था. Why it is given yellow color? Because when it is laid and exposed from top, when you do the filming, you see yellow color. So you understand, oh, this is a cable. So you have to be careful. But for, the maximum the damage so far on the world has happened is because of third-party mistake. Phishing, this, that, किसी और कंपनी का कुछ ड्रेजिंग चल रहा है, कुछ हो गया, आपका केबल है, तोड़ दिया. ये म्यूनसिपलिटी में भी होता है ना, गैस का पाइपलाइन तोड़ दिया, केबल, सेम थिंग देयर. People are same everywhere.
Sir, during the fault, does it affect the marine life also?
Not much.
Not much.
Because they are, first of all, they are very deep. Second thing is they are subsea. Means वो जो बेड है ना, सी बेड में भी पहले जब इसका इसमें था, पहले जैसे हम लोग खेती करते हैं तो ऐसा प्लोविंग होता है, तो प्लोविंग होता रहता है, बाद में केबल आता रहता है. एंड विद इन 4-5 डेज प्लोविंग होने के बाद, केबल इंस्टॉल होने के बाद, आसपास का जो मट्टी है ना वो अपने आप सेटल हो जाता है. सो इसके लिए डायरेक्ट मरीन फिश वेल ये उसको टच नहीं करता. तो उसको टच करेगा तो भी दे डोंट इलेक्ट्रोक्यूट. दैट इज नॉट एन इश्यू. Sorry? No. It depends on the how deep is the penetration. कितना कर दिया है. Because इसमें ना ये डबल वायर आर्मर है, तो वेरी अनलाइकली कि वाटर नीचे तक जा सकता है. बट यू नेवर नो, इफ यू हैव गॉट अ वेरी बिग वेसल, उसका एंकर है तो हो जाएगा, मीडियम का नहीं होगा ऐसा. एंड नॉर्मली ऑल ऑफ दीज इंस्टॉलेशंस आर इंश्योर्ड. अगर कुछ भी होता है तो अल्टीमेटली इंश्योरेंस विल पे, बट देन यू विल हैव टू पे द प्रीमियम ऑल्सो. It's not easy. That's why normally there are no private players in this field, only governments, national oil companies, companies like Power Grid, like that. Yes. आइडेंटिफिकेशन के लिए नॉर्मली कुछ यूज़ नहीं होता है, बट इन वेयर द मोस्ट रिस्की पार्ट इज ट्रांजिशन फेज. ऑफशोर से जब ये ऑनशोर आता है तो दरिया किनारा जो है अपना उसके पास में, तो व्हाट दे डू इज देयर इज समथिंग कॉल्ड मैट्रेस. तो पूरा मैट्रेस लगा देते हैं. अभी आपने रोड पे देखा होगा वो टाइल्स लगा लिखता है 33 kV केबल, तो अपने को देख के लगता है कर अच्छा यहाँ खोदना नहीं है, तो उधर वैसा लिखते नहीं है, बट देर आर स्पेशल मटेरियल एंड इट इज़ कॉल्ड मैट्रेसिस. वो मैट्रेस बिछा देते हैं सो दैट उसके ऊपर कोई मारेगा तो भी पहले मैट्रेस तोड़ने में उसको काफ़ी टाइम लगेगा, तो उसको समझ में आ जाएगा कि इधर कुछ लफड़ा है भाई. विद इन द सी इट डिपेंड्स. फॉर एग्जाम्पल इस टिपिकल गल्फ, अभी ये जो बात हुआ था बे ऑफ खंभात, तो वो और बिटवीन इंडिया एंड श्रीलंका का अभी जो बात हुआ वो 20 मीटर है, तो 20 मीटर 30 मीटर में कोई ज़्यादा प्रॉब्लम नहीं होता है. द मिडल ईस्ट, UAE, ओमान, उधर एवरेज सी डेप्थ इज 60 मीटर, 70 मीटर, 80 मीटर इज मैक्सिमम. इसके लिए उसको गल्फ बोलते हैं ना. गल्फ बोले तो खाड़ी, खाड़ी मतलब महासागर नहीं है, प्रशांत महासागर, इसको खाड़ी बोलते हैं. गल्फ, तो गल्फ बोला तो खाड़ी है. खंभात है तो गल्फ ऑफ कैम्बे, तो शेलो रहता है, उसमें ज़्यादा सी वेव्स भी नहीं होता है, पानी ऐसा स्थिर पड़ा रहता है. एनी अदर क्वेश्चन?
Thank you very much, sir. Actually, we crossed the time, but the topic is interesting, and from audience, we are getting good response, so we are continuing, no problem at all. Now, Surinder Jain sir to share his presentation.
Hello, good afternoon, everyone. Thanks for giving us a opportunity, just for giving us the presentation about the cables. Mr. Bhargava has already explained about the energy requirements till 2030, Mr. Tiwari has already explained about the manufacturing and the testing of the cables. I think nothing is left to me for the presentation, but still I will try.
Huh.
Okay, आप करिए. Thank you.
You can react the problems, okay? Now, sorry for some technical. Now I request Shah sir from KJK Engineering Limited to share his practical experience.
आज का जो सब्जेक्ट था ना केबल, तो आई वांट टू डू सम क्विज. आपको क्या लगता है कि दुनिया में सबसे पहला सबमरीन केबल कब लगाया होगा? एनी वाइल्ड गेस? કેટલા વર્ષો પહેલા લાગ્યો હશે કેબલ, પહેલો કેબલ? 1940. બીજો કોઈ ગેસ? ઓગણીસો 40માં કોની વચ્ચે, શા માટે? વાઇલ્ડ ગેસ. ઓકે, ફેર. એનીબડી એલ્સ? $1850, 1850. Between London and France. અને એ કેબલ છે ને ઇન્સ્યુલેશનના હિસાબે ફેલ થઈ ગયો, 3 વર્ષમાં પૂરું થઈ ગયું. હા, વેરી ગુડ ક્વેશ્ચન. વોલ્ટેજ લેવલ. બટ before that you need to ask what is the purpose? What was the purpose of the cable? At that time fiber optic was not there, no? Wi-Fi नहीं था, internet नहीं था. क्या था तभी? इलेक्ट्रिसिटी इतना वाइड कॉमन था क्या? 1850 से 50 मतलब આપણે કહીએ ને 1857 સ્વતંત્ર સંગ્રામની પહેલા. ટેલિકમ્યુનિકેશન, વોટ, મોર્સ કોડ, ટેલિગ્રામ. એટલા માટે વોલ્ટેજ વોઝ નોટ ઇમ્પોર્ટન્ટ, ઇન્સ્યુલેશન વોઝ નોટ ઇમ્પોર્ટન્ટ. પણ ઇન્સ્યુલેશન જોઈએ, કારણ કે પાણીમાં કેબલ નાખે તો ઇન્સ્યુલેશન તો જોઈએ ને એમ, એટલા માટે એ ફેલ થઈ ગયો. ધેન અનધર ટ્રાન્સ એટલાન્ટિક બિટવીન લંડન ટાઈમ્સ એન્ડ ન્યુયોર્ક ટાઈમ્સ સમાચારની આપ લે કરવા માટે 1857માં કેબલ નાખ્યો. એટલે પ્રેઝન્ટેશનની શરૂઆતમાં મેં કહ્યું કે ટેકનોલોજી પ્રોબ્લેમ નથી. આ પ્રોબ્લેમ છે, પેલો પ્રોબ્લેમ છે, કોઈ જ પ્રોબ્લેમ નથી. પ્રોબ્લેમ નક્કી કરવાનો છે કે મારે નાખવો છે. સાહેબે કીધું કે ફેક્ટરીઓ બધી બુક છે, નેક્સ્ટ 5 વર્ષ 8 વર્ષ સુધી તમે ઓર્ડર પ્લેસ કરવા જાઓ, પેલો કે નહીં ભાઈ આઈ એમ બુકડ ફોર નેક્સ્ટ 10 years, તો તમે શું કરો? હવે ટ્રેડિશનલી ધેર વેર ઓનલી 3 કંપનીઝ. પ્રિસ્મિયન, 2-3 વાર તમે નામ સાંભળ્યું. પ્રિસ્મિયન ઇટલી, પિરેલી કંપની. બીજું નેક્સન્સ, એ લોકોની નોર્વેમાં અને ફ્રાન્સમાં ફેક્ટરી છે. અને થર્ડ જે પાવર. ધીઝ વેર ધ 3 મેજર પ્લેયર્સ ઓલ અરાઉન્ડ ધ ગ્લોબ. એટલે 2005-2007 સુધી અમે લોકો મટીરિયલ રિક્વેશન ઇસ્યુ કરતા હતા, 3 કંપનીને જ કરતા હતા, ખબર છે, એ સિવાય કોઈ આવે નહીં. 2007-8માં ZTT કરીને એક ચાઇનીઝ કંપની છે, જેની પાસેથી અમે આ સબમરીન એકચ્યુઅલ ફાઇબર ઓપ્ટિક કેબલ ખરીદ્યો, ટેસ્ટ કર્યો, ઇન્સ્ટોલ કર્યો અને બરાબર વ્યવસ્થિત ચાલે છે. એ કંપની માર્કેટમાં આવી 2008માં. શા માટે? આત્મનિર્ભર. ચાઇનાને એમ થયું કે આ ખોટું છે, અમે વેસ્ટર્ન પાવર ઉપર શા માટે આધારિત રહીએ, અમે કેમ અમારી પોતાની ફેક્ટરી ન બનાવીએ? तो आ आंसर है, ये अपना आंसर है. अगर भारत में 2000, 5000, 10,000, 50,000 किलोमीटर केबल बनाने का है तो हम अपना फैक्ट्री क्यों नहीं लगाते? मंगलयान तक जा सकते हैं, ये कर सकते हैं, वो कर सकते हैं, तो व्हाई नॉट दिस? ये आपके थ्रू आप मोदी को बताइए. और अभी सो when we floated the inquiry to ZTT, हमको इतना अच्छा प्राइस मिला. At that time I was in abroad. My management asked me to go to visit the ZTT. I went there and I found कि उनका फैक्ट्री है ना, वो प्रिस्मियन की फैक्ट्री में बाहर 12 टाइम्स में गया था. उसका एक एक मशीन से इसका एक एक मशीन लेटेस्ट था, परफेक्ट था. मैं कुछ मिस्टेक निकाल ही नहीं पाया. मैंने आके मैनेजमेंट को रिपोर्ट दिया कि देयर इज नथिंग टू वरी अबाउट, देयर इज नथिंग टू कंप्लेन अबाउट. और बराबर टाइम पे बाद में मैं जो पूरा केबल हो गया तो OTDR टेस्टिंग, दिस टेस्टिंग, वो सब करने के लिए गया मैं. परफेक्टली ऑल राइट, कोई प्रॉब्लम नहीं. तो अभी भारत को ये बनाना चाहिए. हमारा गुजरात अलोन 1600 किलोमीटर, वो जो आपने मैप दिखाया था, खंभात से डायरेक्ट बॉम्बे, भावनगर से इधर उधर, ये सब करने का है. इट्स पॉसिबल. इसमें कोई रॉकेट साइंस नहीं है. इनफैक्ट रॉकेट टेक्नोलॉजी में भी रॉकेट साइंस होता नहीं है. स्मॉल 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 थिंग्स, इफ यू डू वेल यू मेक अ रॉकेट. सबमरीन केबल इंस्टॉलेशन डिज़ाइन के बारे में, प्रोजेक्ट के बारे में, टेस्टिंग के बारे में, सर्वे के बारे में, जो भी आपके मन में प्रश्न है पूछिए. ये मत सोचिए कि ये बहुत सादा सवाल है, नहीं पूछना चाहिए. नो, पूछो. अच्छा, कोई बोल रहा था ये छोटा डिस्टेंस के लिए नहीं बना सकते. नहीं, आप में से कई लोग लंदन गए होंगे, फ्रांस गए होंगे. लंदन में थेम्स नदी है, पेरिस में सीन नदी है. आपने कभी एक ऑन वन बैंक आपने बैठ के देखा क्या कोई ओवरहेड लाइन जा रहा है? देखा जिसने कभी गया है? नेक्स्ट टाइम जाना तो देखना. कोई नहीं है. वो सारे केबल हॉरिजॉन्टल डायरेक्शनल ड्रिलिंग करके वो लोग ने नदी के नीचे से केबल ऐसे ही लेके गया. किसी ने ओवरहेड ट्रांसमिशन लाइन डाल के पूरा लुक्स बिगाड़ नहीं दिया है. सेवरल. सो ऐसा आई मीन यू विल फाइंड हंड्रेड्स ऑफ इंस्टॉलेशन अब्रॉड and it is the most reliable, I would say, the most reliable. सिर्फ एक ही केवल रिक्वायरमेंट है कि आपको काम अच्छे से करने का है. अगर वो बराबर रूट सर्वे बराबर नहीं किया, केबल इंस्टॉलेशन बराबर नहीं किया, डिजाइनिंग बराबर नहीं किया केबल का, देन यू विल हैव ट्रबल. एक बार आपने सब अच्छे से कर दिया, 40, 50, 60 ईयर्स तक कोई प्रॉब्लम नहीं है.
Continue, sir. As far as life is concerned, and how can we predict the life, remaining life of the cable?
Actually, the life expectancy of a cable, of this kind of cable, is 60 years. And one of the best diagnostic test of a cable is to do the partial discharge test, PD. हम जो घर में वायरिंग करते हैं ना उसमें वो लीकेज टेस्ट करते हैं. हमने वो RCBO, RCCB, ELCB काफ़ी सारे नाम है वो लगाते हैं. उसका सेटिंग रहता है 30 मिली एम्पियर, 100 मिली एम्पियर एंड 300 एम्पियर मिली एम्पियर. फिर 30 मिली एम्पियर में वो टेस्ट आता है, बटन दबाता है, ये वो चल रहा है. बट इट इज़ नॉट ऑपरेटेड. इट मीन्स हमारा जो घर का वायरिंग है उसमें करंट हैज़ नॉट क्रॉस्ड 30 मिली एम्पियर. बस बिकॉज केबल इज इन ऑपरेशन. मतलब बाई डिफॉल्ट कंटिन्यूटी है ही ना, पावर आ ही रहा है तो आपको कंटिन्यूटी टेस्ट करने का जरूरत नहीं है. सो दो रहा, एक पार्शियल डिस्चार्ज टेस्ट और एक दूसरा हाई वोल्टेज टेस्ट टू नो द हेल्दीनेस ऑफ द इंसुलेशन. बट नॉर्मली यू डोंट डू बोथ, क्योंकि ये जो केबल है ना ऐसा होता है कि उसका अगर बैकअप नहीं है तो आपको ये टेस्टिंग करने के लिए आपको शटडाउन लेना पड़ेगा. तो इट विल बी वेरी डिफिकल्ट. Okay. Now it depends on the, as I was telling before, your demand. For example, this cable we have installed was 36 kilometer long.
Okay, 36. So 36 kilometer, are they able to test in single go?
Yes. It has to be tested. Otherwise, for example, I am a buyer. I am buying cable from him.
Distance will be very, very high.
I am buying cable from him.
I think this is a medium voltage cable.
Sorry?
This one is medium voltage.
This is 40 kV.
Yeah.
Yeah.
I think if it is 40 kV, it is still maybe you are able to test. But in case of VHV or higher rated or cables,
Even if 5000 kV technically not in production, टेस्ट तो होता ही है ना. जो भी चीज़ें बनाते हैं वो सबका टेस्ट होता है. IC तो है ही ना. और
No. Actually, he is talking about the test, high voltage test after the installation. You want to say कि just we have to test the cable system on a high voltage. Means कि we are using a HVAC resonant test apparatus. So
I'll tell you. After it is called mechanical completion. It means you have laid. Now there was a J tube, offshore platform. If there is a J tube. If there is no J tube, nothing. But before you energize and start transmitting the power, you have to do the testing. And HV test is must. HV is what? Whatever is your rated voltage. For example, 40 kV. I will apply 60 kVA, 1.5 times. When there is a water pipeline or any fluid pipeline, there also you do mechanical test pressure. Is what you do is, it is a universal standard, 1.5 times. 1.5 times of the voltage you are going to use it, you test. And who said if it is a 30 kilometer, it can't be tested? Very much it can be tested. Your testing equipment should be able to deliver that much of current, which 36 kilometer is a leakage should deliver. But there are equipments available in the market. Otherwise, when I purchased this cable, it was $18 million was the PO cost. It means I am taking the delivery of $18 million cable. Do you think I will not test? I will have to test. Anyone will have to test.
So test facilities are available for this
Yes,
long
Prysmian is having a factory at Naples.
The factory is okay.
Yeah.
I'm talking about site testing.
Yeah, of course.
And even this PD for this long length normally, okay, we are doing an extra high voltage and all. So there is no chance to put any PD collector or anything in between. So that this PD can be done for long length of 36 kilometers.
No, this continuous length, is a requirement.
this is still optional because dammed for a longer distance cables. Because when you have a longer cables, say even the 5,000 meter, the PD pulse is getting dammed.
सर 5000 मीटर कुछ नहीं है सर, मैंने तो 90 किलोमीटर तक का देखा है. इसके लिए वी शुड हैव वो कहीं पे लिखा था, मैं आ रहा था ना, गुजरात रीजनल वैश्विक महत्वाकांक्षा समथिंग. So we need to, you know, to reach that level.
सर इवन जो आईसी सबमरीन का सिगरे है 490, वो पीडी के लिए बोलता है लंबी लेंथ पे हो नहीं सकता, इट कैन बी डन ऑन सैंपल, इवन हाई वोल्टेज ऑल्सो.
होता है, सब होता है. एनीवे अभी वो उस प्रकार के प्रोजेक्ट हमने किए नहीं इंडिया में कभी किसी ने. इसके लिए नहीं मैं अभी आपको कौन बोल रहा था कि ये जो केबल है ना, उसका केबल टर्मिनेशन किट हम बनाते नहीं है, 3M बनाता है, यही बनाता है. ना आई एम जस्ट टेलिंग यू, केबल तो हम बनाते हैं बट टर्मिनेशन किट नहीं बनाते हैं. ऐसा
The production of every equipment depends on the requirements, because in India
Commercial
there
sense नहीं है ना.
is a very few requirements of the 400 kV cables and above. Only 1 or 2 utilities are using, and very low quantity are being used by the NHPC. That's why just we have started the 400 kV cables manufacturing, like 1 or 2 companies in India. Still, we don't have many orders in our hand.
Correct.
So, but because just we are in discussion with the many PD equipment manufacturers. So we have discussed a lot, and we are also struggling with in the exports also, where we are quoting a long length cables. So they are not able even to test the land cables where the route length is approximate 10 to 15 kilometers. So that's why Mr. Garg was asking, is there possibility to test the...
Maybe the material science, what you are using, what kind of insulation, etc.
It is XLP.
Is it excessively drawing higher leakage current?
No.
It cannot
we
be.
are using XLP only.
XLP only. Yeah, and that is much lower than that paper insulated cable.
So then it should not be.
And even sir, high voltage cable, if you are doing the soak test for long run, that I mean,
It's a very big reactors at the side.
yes.
And it's you can say it will be more than cable. You will be putting reactors at the side.
Yes.
For testing.
Okay. A bit now it all depends on the EPC scope. Who defines the scope?
Sir, but as per IC also this is requirement. All the cable manufacturers have to do it after the laying. AC and DC test, they have to do it.
Sir, if you refer this Sigre 490, that says because for longer length you are making factory joint for longer length. So you cannot do the high voltage test on long length.
उनका
So
ready हो गया?
it has to be done on individual length and then sample length.
Presentation ready हो गया उनका?
So, sir, but there are agencies available in India also who are doing for the long length
How much?
cables.
कितनी length के लिए?
Sangor India is there. Who is
कितनी
doing
length के
this.
लिए? कितनी हम मालूम है? We are in touch with them. तो कितनी length के लिए?
What they are doing is they are opening the link box and then they are applying. Because this is in a segment.
Yes.
I think really testing is a really very debating exercise, and we can make so many work on it, and then something can come out, because whenever some higher level is going on, at that time such kind of issue occurs. Now presentation of Jain sir is ready, so I request him to present.
Hello? So, Mr. Bhargava has already explained the requirements of the energy. Approximate 500 gigawatt is to be required to be generated and transmitted since 2030, and most of the renewable energy is being transmitted either by the solar energy or by the wind energy in both modes, either the offshore or the onshore. So anyway, the cables are very much required just for transmitting these powers once we are generating this much amount of power. So generally the cables are being considered as a nervous system of the cable system. But in any case, when we are supplying the cables, so just we must ensure the cables has to be reliable, the cables must be completely durable. So basically, just when we talk about a EHV cable system is nothing but a combination of the cables, cable accessories, and finally the monitoring. The cables generally includes the main cables through which just we are transmitting the power, that is called extra high voltage cables. Then the bonding cables, what are required just for the sheath bonding methods, coaxial cables, and the earth continuity cables. The accessories are required, either we have to terminate the cables in the end, so the terminations are required, either the indoor terminations or the outdoor terminations as per the requirements, then the joints, and finally the link boxes. And now we are talking about the reliability of the cable system, so it is very much necessary to monitor the installed cable system. So there are many methods we can monitor the cable systems, like we can install the DTS for monitoring the temperature of the cables, then the DAS just for monitoring if something excavation is going on or not, then sheath monitoring system we can use, and PD monitoring system we can use. The main constructions are relevant in India right now. The cables are being supplied either with the lead sheath, which is mainly being supplied in the coastal areas of the India, like West Bengal, Maharashtra, in some part, Karnataka, Kerala, and corrugated aluminum sheath cables, which are being very popular because of its economical issues, and the polyol tape. Generally, the polyol constructions are being used only in the Gujarat, especially for the lower voltage, like the 66 kV voltage cables. Now, but the worldwide now, the most of the other construction are also acceptable. Now the smooth aluminum sheath is very popular in Europe and in other parts of the world, because in the case of the corrugated aluminum sheaths, the diameters of the cables are very high as compared to the smooth aluminum sheaths. So we can transport the less length of the cable. So just to being transport the more length of the cables, so we can supply the cable with the smooth aluminum sheath. Apart from this, the corrugated copper sheath cables are also an option instead of the corrugated aluminum sheath. And in some areas, we are also supplying the corrugated stainless steel tape cables. The sheath, generally the HDP sheath is being used in the EHV cables because it's better abrasion properties. But now generally in the substation systems, substations, we are also supplying the cables with the HFFR materials with a grade of ST12. These are the typical construction drawings which Mr. Tiwari has already explained. We can supply the cables with the embedded optical fiber cables in all type of construction of cables. So the main function of the optical fiber cables in the cables is to monitor the temperature of the cable. These are the typical constructions of the cables: corrugated copper sheath cables, smooth aluminum sheath cables. This is the corrugated sheath with the nylon sheath. Generally, the nylon is being used as an anti-rodent in the anti-termite application. These are the typical drawing of the submarine cable, which we already supplied in one of our export projects. The cables were being laid at a approximate depth of 40 meters, and the cables are working satisfactory. But the cables were being supplied was a 22 voltage kV grade. These are the cable accessories, the terminations, indoor and outdoor joints, link boxes, and the smart cable monitoring. DTS, DAS, PD monitoring, and the sheath monitoring systems. These are the types of the terminations. These are the dry type terminations. In India, now we are installing up to the 132 kV. Mainly we are installing the dry type outdoor terminations. This is very easy to install, especially on the towers, where now the trend is increasing. More and more termination has to be installed on the towers. But now the worldwide, there is trend is increasing. The terminations up to 220 kV. Now the dry type terminations are coming in the market. Joints, we can supply the joints as per the requirements, either the with or without coffin box, with or without metallic casing, depending on the environmental conditions, depending on the mechanical requirements. Link box. Generally, the link box are being used for terminating our cables, either at the termination end or for using the cross bonding of the system in a longer length. But now some of the world companies are supplying in the name of the intelligent link box. So the function of the intelligent link box is you can monitor the PD system, PD, you can monitor the sheath monitoring, you can check the humidity, you can check the water ingress, you can check the internal pressures in the link boxes. These are the typical photograph, how we can install the HFCT sensors in the link boxes just to monitor the PDs. These are the active online monitoring, DTS, just to monitor the temperature of the cable. It is not only just you can check or you can monitor the temperature of the cables, but in case, let us see, generally the RTTR is also being installed in the DTS. So the main function of RTTR just to check the cable temperature, and it can guide you about the current ratings. Let us see if you have installed two systems in two circuits in parallel, and your one circuit is idle. Let us say you have taken it for a preventive maintenance. So you can check at the other system. You can load your other system for how much duration and for how much current. So that will help out. These are the typical photograph for the PD measurements in the monitoring. These are the sheath monitoring. Generally, when we are doing a cross bonding in a system, so there are chances that sometimes our sheath are being damaged during the laying of the cables, or after some time is the sheath. So there are the circulating current in the sheaths, which will may cause as a failure to your cables. So you can check the sheath current in each major section, so you can check the healthiness of your system. Thank you.
Thank you very much. If any question from audience side? Okay. Thank you. Yeah.
Means before putting on load, you must test your cable for 24 hours at no load.
Any? Okay, thank you.
Thank you.
Hello. Actually, we have taken lots of time than our scheduled time. And in between, we have made already panel discussion. So we will skip it because we already made lots of discussion which can be included at the end of panel discussion. Now with this all discussion, right, our goal was to capture the power from offshore wind farm, and we have to laying a cable undersea. Then what should be the probable challenges, in which direction Gujarat or India has to work, what BIS role will be, and how we are prepared for testing and other things. So from this seminar, we come to know that we have enhanced our understanding about the advanced cable system for offshore. We also understand from here what are the different parts of the marine cables, and we have seen the parts of the cable also. That's really very great, because we have never seen the marine cables. How the whenever some anchor will strike on it, then how its effect maybe we can visualize it once we have seen the construction and so on. Another thing is what are the different parameter need to be considered, and how the BIS giving the numbers or permissions, and so the customer may become we can say no fear. Once you have a BIS number, then we have to purchase that cable, only we need to test it and so on. So with this, I hope this conference is fruitful, and in coming year India will be the leader, and I hope sir has said that rightly, when we want to do something, actually it is a very mature technology, we need to develop only ecosystem, right? So if we be deterministic, then definitely cable will be manufactured on the land of India, and then we can say we are in really true sense that we are Atmanirbhar in marine cables, and we can capture the power wherever available, either it is on land or into the sea. Thank you very much. Here, now I request Rathod sir to make end of the session. Vote of thanks, yeah.
Thank you, dignitaries, for your time. Thanks for enlightening us with planning requirement and terrain consideration, our limitations, selection and economics, including transportation limitations, standards, protection and safety aspects, material selection, copper or aluminum, insulation selection, accessories, and environmental impact. We are greening our electricity sector, but with this we could not pollute other sector. With this thought, and with the planning of CTU and NTPC, when we have planned, we have decided we will do it. With this, I am conclude this session. Thank you very much, sir. Thank you very much, dignitaries, for enlightening us for this thought. Thank you.
Thank you very much, A.B. Rathod, sir. To move ahead, to end this session, and to make this event more memorable, I would like to invite A.B. Rathod, sir, on stage to give mementos to each our esteemed speakers. I request A.B. Rathod, sir, to give to Dr. R.D. Bhagia, sir. I again request A.B. Rathod, sir, to give memento to Professor K.S. Swaroop, sir. Shri Sumit Senjar, sir, is requested, and A.B. Rathod, sir, is requested to give memento to Sumit Senjar, sir. Okay, sir, we will give it later on. Okay. Now I request Sri G.H.N. Rao, sir. I request Sri Adarsh Singh, sir. Thank you, sir. I request Sri Yogendra Tiwari, sir. Thank you very much, sir. Now I request Sri P.K. Barasra, sir, to give mementos to our dignitaries. I request Sri Surindra Jain, sir. Thank you, sir. Now I request Sri Jinesh Shah, sir. Thank you very much, all participants, esteemed speakers, for your valuable time. Thank you very much.